Good evening.
Audio cut out.
What's going on?
Hear me on Zoom? Okay, good. So we'll start with the Pledge of Allegiance. Danny, if you could, you got a full mouth.
Gets me with a full mouth. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Two.
Why don't you take it from there?
Okay. You're going to introduce? Okay. I have some urgent thing we have to address right away. We have a new member, Ray, WA6NVL. You probably remember him from the Visalia. He was here at the last meeting, and he's been around for quite a while. Some of you know him from some other organizations. Yes. Yep. And this is his second meeting, so we need to vote on official vote. That's right. Now, Ray's working on getting us 100 countries, and I think he's found FT8 to try to close the gap there. So he'll be an associate member until he gets his 100 countries knocked down. So, but it's time for us to see if we want to vote him into the club. He's up there. He's in the black hat. There you go. Thanks, Ray. He introduced himself. He introduced himself last month and gave us a background on him. So I don't think we need to hear that again. So anybody want to make a motion to accept Ray into the club? Okay, a second. All right. All in favor? Aye.
Aye.
Any opposed? No opposed. Ray, you're up. So you're good. All right, Ray, you can go to your other meeting now.
Yeah, I've got a HOA board meeting to do. Wow.
Okay. I think Bud's going to take care of the introduction for the speaker. For those of you that are on Zoom, if you look, I've got my iPad set to look at the speaker. So you'll see that's what's up front there. So if you click on that and you pin that to the top, you should be able to see that also when the speaker's talking. So just FYI, I got the feeling you guys didn't get to see what was going on in the room when the speaker's talking. So I'm trying to fix that. So here you go.
Okay, so our presentation tonight is from Eric Gruff, NC6K, who we used to see at the meetings a lot more often, but hey, we haven't really seen you since probably pre-COVID, and you've been busy working. But Eric's quite a presence in the 6 meter world and other contesting stuff as well. But knowing his 6 meter prowess, we wanted to get him back for his presentation on Sporadic-E propagation with 6 meters. And he's been around for quite a while. I'm not going to read all of his intro that he had was in the newsletter, but one of his main claims to fame is you're pretty close to your Fred Fish Memorial Award, which is quite a feat in and of itself of getting all the continental grids in the U.S. on 6 meters. Does it matter what mode when you do that? Any mode. So you're going to talk about it. Cool. But as we know, the 6 meters is the magic band, and it's coming into vogue right now as 6 meter Sporadic-E season kicks off here. So without further ado, let's hand it over to Eric and let him get going on his presentation.
Pretty loud anyway. So I'm Eric, NC6K. I have been a member of the San Diego DX Club since 2014, 2015. I do apologize for not being at more meetings, blame it on work and family, but it's really great to be here and see a lot of you. I am not the world's expert on 6 meters. I probably have learned a lot of what I'm going to tell you about just through trial and error. The empirical learning method, I guess, is what you'd call it. But I will share what I know with you, and I will share what I don't know with you. And I would encourage all of you to make the best of what you learn here and maybe come back next year and teach me a few things about 6 meters. Because in the 20 plus years I've been on 6 meters, I have to say, the more I think I know, the less I actually know. So that being said, let's dive right in. Yeah, it's true of most things in life, actually. You're right. Okay, so I'm going to give you a quick bio because everybody's like, who is this guy? I always like to hear about other hams and find out what they do outside of ham radio. And so I'll keep that pretty quick, hopefully. I do have one slide because well, I'm missing a parentheses there. See, my OCD is going to kick in on that one. But anyway, I do have one slide where I want to talk about how things are today because we're approaching the peak of solar cycle 25. And as we all know, when the solar cycle gets near the peak, not only do we have sporadic-E propagation on VHF, but we may see some F2. And that's when things get really exciting on 6 meters. So I have one slide. I just talk about that. So this isn't so much a sporadic-E presentation as it is a 6 meter operating presentation. I hope you'll forgive me, but it's probably more useful that way. And then I'm not going to read the whole slide, but basically I'm going to talk a lot about sporadic-E because I think a lot of folks either don't know much about it or have heard a lot of weird stuff, anecdotally that isn't true necessarily. And then a little bit about operating tips to make your life more enjoyable on 6 meters and etiquette so everybody else's life is more enjoyable on 6 meters. All righty. And I do encourage you to interrupt with questions and things. I like to be informal. I'm not going to be offended if you want to put up your hand and ask a question, or you can save them for the end, either way. I charge by the question, so it doesn't matter to me. Okay. If I had to sum up my 6 meter thoughts in one sentence, it would be prepared to be disappointed. Every year, as we get towards, this is a great time of year, by the way, as Bud said, to have this presentation because the sporadic-E season is primarily the end of May through the end of July. I'd like to think it's longer, but in reality, that's about it. So every year about this time, it's like baseball season or football or pick your sport. Your team starts the season with a 0-0 record and everybody's the optimist. We're going to do it this year. And then a month in, you look back and you go, well, maybe next year. Anyway, so this is tongue in cheek, but manage your expectations. 6 meters can be very good or very bad. I will. Absolutely. So, okay. Quickly about me. I've been licensed since January 77. I think my license came in the mail. You remember you used to get the license, you have to peel off the edge and then open it up from the FCC. I think my license came in like January 5th, 1977. I was 13, typical nerdy kid. My best ham friend was Steve Bloom. His call was WB2IDP. He's now KL7SB, and he runs the KL7RA contest station up in Kenai, Alaska. Jim has been up there quite a bit. I've been up there quite a bit. I'm trying to think if anybody else has been up there. But if you really enjoy contesting and you enjoy Alaska, that's a great place to go. Steve and I have been friends for, 47 years now, I guess. Yep. So like everybody else, I went through school and college and got an opportunity to come out to San Diego for a postdoctoral position in 1990. So I came out and figured I'd come out here for 2 years, enjoy San Diego, and move home again to New York, which is where I'm from, Long Island. And so I didn't change my call. I kept WB2KIH. And by then, FCC had relaxed everything. So you didn't have to, you put a /6 and you didn't have to get a new call. After a while, I realized this is pretty stupid. I didn't do a lot of operating in the 90s. It was kind of just casual stuff here and there. In the early 2000s, I really started getting more involved in contesting, and I realized I got to get a new call. For one thing, everybody thinks I'm on the East Coast, and for another, a 2x1 call is a hell of a lot better than a 2x3 call. So I got my vanity call that I have today. In July 2006, I moved from Rancho Penasquitos over to Poway, which is where I still live. And in 2016, thanks to NN3V, who's unfortunately a silent key, and a lot of other folks in Poway, I was able to put up a tower finally and put up a 55-foot tower with a stepper and started going from there. I'll talk about that briefly. In 2016, I actually realized also that a stepper is not the best antenna. You can see I made it 7 months. And then I went out and bought a real 6 meter antenna, which I put on top of the stepper up on the on the tower. Personal stuff. I've been married to my wife. We just had our 28th wedding anniversary in 2 weeks ago. And a week ago, and I have 3 children. My twin daughters, some of you know, live with us still. My son's in Evansville, Indiana. I'm a chemist by training. I work in the pharmaceutical industry. I haven't been doing enough bicycling lately. One look at me will confirm that. But I used to love to do a lot of road and mountain biking, woodworking. I still do a lot of, and playing the guitar. So that's everything you need to know about me and more. So 6-meter gear, as I said, the first 16 years of being a ham, I had no radios that were capable of 6 meters. For those of you that remember, until the transceivers started coming out in the early 90s that were HF plus 6 meters, you had to have a dedicated radio for anything above 10 meters, basically. And they weren't cheap, and a lot of them were AM only or AM and FM. So you didn't just go to the store, pick up a transceiver, and just get on all the bands. You had to really be dedicated and a little bit motivated to work on 6 meters. And certainly above that, even more so. I had a 2-meter FM radio, but that doesn't count. Then I picked up my first real transceiver, which was the ICOM 736, and it had 6 meters. And I probably pushed the button a couple of times and tuned around, didn't hear anything, and said, "Oh, this band's dead." So I had a Cushcraft R7 vertical, which basically has no gain in any direction. What is the definition of vertical? It radiates equally poorly in all directions. But, you know, and I didn't have an amplifier. Yeah. But in all seriousness, you know, 6 meters was like, I tried to see if I could find some repeaters. And other than that, I didn't give 6 meters any thought. I may have gotten on FM, as I said. Then in 2002, I started hearing about Sporadic-E propagation. And I think we were at the peak of a 23, was it then? I've lost track. No. Yeah, 23. Yeah, cycle 23. So I actually started also getting much more interested in back into contesting. So I got rid of the ICOM 736, picked up a 756, which I kept for a little bit, and then I picked up the real radio, the monster, the ICOM, the ASUF TDX 5000, which is a great radio. And it also had 6 meters. But at this point, in talking with people, I realized that I had to go and look at CW and sideband for 6 meters. There were really not many digital modes. If you talked about digital in 2002, people assumed you meant either RTTY or PSK31. So I did start getting on 6 meters a little bit, starting in 2002. And because I could run 200 watts, on CW, along with the hex beam that I had put up, which actually did load up on 6 meters pretty well and work. I've made a few contacts. I've made a couple of PSK 31 contacts on 6 meters. I don't know who I worked. I don't remember. Probably could look it up. But, that was my first foray, and it really got my interest going. I don't think I worked anybody east of Colorado, but just the fact that I can make contacts on 6 meters was really exciting. So then as time went on, I started, trying to evolve the station and get more and more involved. By the late 2000s, the first decade of the century, I really was getting into it. By 2008, I was on 6 meters a lot, especially in the summertime. And I had picked up a power amplifier. Back then it was a tube amp of some sort. I don't think it actually covered 6 meters. So I was still running low power, but in the mid 20-teens, I switched over to a flex. I got an amp, the SP Expert 1.3 KFA, which I don't know how many of you know the Expert amps. I'm not a big fan of solid state amps, at least I wasn't. And I used that for a long time on 6 meters. And I upgraded my antenna. This is actually my current setup. That's a OptiBeam. It's a 6-band HF beam. I use that for contesting and everything else on the tower. The tower looks like it's nested there. But if you look above the big OptiBeam HF beam, you'll see my right there. There's the boom. It's a 24-foot boom, 7-element antenna on 6 meters. It's a really nice antenna. It's Innoventanus. I've never been able to pronounce it. And I, added a preamp on the mast and everything else. So I'm looking at something like 12 dB of gain over an isotropic radiator, which is more like 10 dB of gain over a dipole. But it's a really nice antenna. In fact, it's probably too much antenna, and I'll talk about why in a minute. But if you feed this antenna with 1500 watts, the effective radiated power is about 15 kilowatts. So it really puts out a nice signal, and the results have spoken for themselves. It also receives extremely well. I've had a lot of cases where I could hear stations that a lot of the other locals couldn't. The drawback is if you're not pointed at somebody, you're not. So if I'm pointed at South America and there's an opening to New Zealand, I may not know it until I see spots on the internet. Because it's like a John NA6L, who's not with us tonight. He goes, I have a flashlight and you have a laser. And so there's advantages to both, but I'll talk about that. But, you know, it's something I didn't really think about. I just, you know, bigger is better. I wanted to have as much gain as I could fit on the tower. And so I basically went with the 7-element. I don't regret it, but it is something to consider depending on what your, you know, what your desires are going to be for operating on the band. What's that? It's deceiving. They're about 5 feet apart. There was zero interaction. I played around, and just because of the nature of how the tower's set up there, and I have to have the tilt plate. Oops, sorry about that. The tilt plate here enables me when this is a tilt over tower. So I tilt it over and the tilt plate keeps the antenna parallel to the ground so I can work on it without a ladder. So that kind of limits how much of a mast I can put above the HF antenna. But I have seen basically zero issues with having it 3 or 4 feet above the HF antenna. And I might just be lucky. It's better to be lucky than good, as they say. But it does work, and like I said, I haven't had any major issues. Before I had this this HF beam, I've had 2 different steppers. I had a huge DB36 on a 36-foot boom, which is much larger than what's up here. And the trees in the yard got so big that I couldn't lower the tower anymore without the stepper getting caught in the trees on the way down and falling apart. So I took that down and put up a DB18, which is half the size. And I had many, many problems with it. And I don't want to bash stepper, but it's not my cup of tea, especially for contesting. So this is an Innov Antennas 6. This covers 40 through 10 meters. It's 2 elements on 40, 30, and 20. It's 2.5 elements, whatever that means, on 15, and it's 3 elements on 12 and 10. It works really, really well. And the nice thing is it's instant band switching. So in other words, the way it's a really well-designed antenna. You have 1 feed line and it covers 6 bands, and it covers them pretty well. It's not a monobander, but for what we're only allowed to have 1 tower in Poway. I mean, the fact that we can even have one is a godsend, but you know, I had to compromise here. So I went with something that works really well. I'm really pleased with it. I would absolutely recommend this antenna to anybody for DXing or for contesting. Okay, so again, you know, here's just cut to the chase here. So for those of you that are into antennas like Randy, this is the azimuthal pattern. So looking down at the antenna, it has about a 12 dB gain, as I said, and the 3 dB bandwidth is 45 degrees. So it's 22.5 degrees on either side of where it's pointed, meaning you should see a lot of degradation as long as you're, you know, pointed somewhere within about 20 to 25 degrees of what you're aiming at. But this is actually a pretty sharp pattern, believe it or not. And this is the elevation gain. So, you know, the biggest lobe, of course, is, I forget what that is. I think it's about 4.5 degrees off of 0. And then this one's about 9 or 10 degrees off of level. So it has a really nice low angle, sharp beam width. When you're pointed at something, I can't imagine that any other antenna would work much better than that. But it does have the drawback of being extremely focused on what you're aimed at. So you have to be aware of that. Okay, I talked about the expert amp that I had. I managed to burn this thing up 3 times. Now, this is not overdriving the amp at full power all the time. I used it for FT8 for, oh God, a couple of years at least. And essentially what happened was, once in a random while, for some reason, I don't know what I did differently, I would usually run about 800 or 900 watts. So I'm running the amp maybe 50 to 60% of max. I'm not overdriving it. I was really careful with ALC. I was running into this antenna that has an SWR of like 1.08 to 1. It's not a tunable antenna. It's a fixed antenna with a very low SWR. And for some reason, the amp would just decide to burn up. The first 2 times I was on 6 meters. I mean, VHF is harder on amplifiers than the lower frequency bands are until you get down to 160. That's a whole nother thing. But the 3rd time really irritated me. The first time it was under warranty, and Bob Hardy, I forget his call, he's in Texas. He does all the service for these amps. It's an Italian amp. And he blamed me for it. He said, "You must have done something wrong." So he said, "I'll fix it under warranty, but, you know, make sure you have a cable plugged in so the amp is, you know, switching based on the frequency coming out of your radio." I followed all his instructions. About a year later, I'm running 800 watts and I start smelling this weird burning smell. I stop immediately. And of course, the amp had burned itself up. It was a single BL, what is it, a 258? the BL250. I forget the final transistor. Anyway, the third time I was on FT8 on 80 meters. I had turned the power down to about 750 watts. Now, I don't normally run FT8 at high power other than 80 meters, 160 meters, and 6 meters. Those are bands where more power sometimes is needed. If I'm on 20 meters, I'm not going to run 700 watts in FT8. There's no need for it. So I'm sitting there running it, and all of a sudden I smell this, you know, hams know what burning electronics smell like. We've all smelled them, right? So I immediately stopped transmitting. I had only smelled it for 5 seconds, and the smoke just gets denser and denser coming out of the back of the amp. I pull out the plug. It's, you know, it's 220 volt supply. And I pull the cover off, and this is what I see. There, what's left of the RF, the MOSFET power transistor is here. This is a choke on the output. You can see I basically burned right through the circuit board. You know, I was at a loss. I sold this amp to John, NA6L, for a third of what it was worth. He sent it back to Bob, got it fixed, and he uses it as a backup amp. But I really have gotten a sour taste for this brand of amplifier because the problem is the RF deck. It sits on top of the rate of the amplifier, and there's very little space between the RF deck and the top of the amp. So heat builds up in that. It's almost like a sauna. And eventually, I think you just get a thermal runaway. I'm not an electronic engineer. As I said, I'm a lowly chemist. But, you know, it's very clear the design of this amp does not dissipate heat the way it should. Now, their high-end amp, the 2K, is a very robust amp. My friend Steve up in Alaska uses many of them on the contest station, and they run full power CW and sideband for 48 hours at a time without issue. So I think it was really this amp that, you know, this design, this model that has the problem. But my point here is not so much to bash SPE and their amps, but rather to remind you that if you're going to run a solid state amp, and it's really nice to have a solid state amp, so you hear a DX station, you flip the amp on, and 2 seconds later you can use it, as opposed to tube amps that take 3 minutes to warm up. And then you've got to tune them in many cases. But if you're going to use a solid state amp, you need to really nurse it, especially with digital modes like FT8. You're transmitting 13 seconds out of 30. That's a lot. And you will build up a lot of heat. So just be mindful. I'm sorry to dwell on this, but it's a lesson that I've learned painfully and expensively, and I'd like to prevent everybody else from having the same issue. Okay, so that's enough about me. Just very quickly, some interesting facts. I just find these humorous, and hopefully you will too. So I've analyzed my digitized QSOs, which go back to June 2012 for 6 meters. I've made about 8,600 QSOs on all the different modes. Those of you that know me know my favorite mode is actually CW. If I never operated on sideband again, I'd be happy. Sorry, Levi. And FT8 definitely has a purpose, and on 6 meters, it definitely has a purpose. It is a great weak signal mode. And if you are a snob and don't want to do FT8, I guarantee you will not work as many stations and countries and zones and states and whatever you're trying to work on 6 meters as you could if you employed them. Unfortunately, it's taken over to where it's the only mode on 6 meters. That makes me sad, but I'm not a snob. I do think FT8 has its purpose, and I use it a lot. I will freely admit I would be nowhere near where I am if I weren't for FT8. My first non-California QSO back in 2012, at least that I know of, was on CW, a whopping 600 miles to New Mexico. I was floored. Wow, New Mexico. I was like 600, 800 miles, 600 miles. Then I discovered JT65, the first of the digital modes. If you remember this mode, you transmit for like 55 seconds out of 60. So you talk about a mode that's going to generate a lot of heat. You transmit for 55 seconds, and then you have 5 seconds for the switch over to the other receive side, and then you receive for 55 seconds. So it's not a very good mode for a band that's rapidly shifting in terms of conditions. 6 meters is the epitome of that. So JT65 was great. It is a weak signal mode, but it is not a great one for VHF. So that was my first contact. That was a whopping 1,000 miles all the way up to, I think that's Oregon. It might be Seattle even, probably Seattle. And then more and more operation. 3 years later, I made my first contact to Europe, and I probably almost fell off my chair. I'm sure I was probably talking about it for a month. I mean, to work Europe on 6 meters back then was like, oh my God. The same day, we had a really nice opening that morning. I managed to work Guernsey, which is GU, Gulf Mike, which is Scotland, of course. And I got halfway through an opening a contact with Ireland, but in the middle of the 55-second cycles of JT65, the band died. And then it came back, and then I tried to work somebody else, and then the band died. And this went on for about an hour before the opening closed completely. At that point, a lot of us were on the chat boards complaining about this mode sucks. It's too slow for 6 meters. You know, we got to have something better. There was an awful lot of that. In early summer of 17, this guy got on K1JT and said he and this other ham, Steve Frank, were working on a new mode that would probably improve upon JT65. It's called FT8. The F is for Frank, the last name of Steve Frank, who's K9AN. And T is for Taylor, Joe Taylor, who, by the way, has a Nobel Prize in physics. The reason he got into weak signal modes and developed all these digital modes is because they use a lot of these algorithms to process very weak signals from astrological bodies and astronomical bodies. I'm going to write. Yeah, things far out there, right? So the man is brilliant, and he is really, you know, he's put in so much. He and his team, a lot of his postdocs and grad students all contribute to this. We owe them a huge debt of gratitude. Anyway, interestingly, I downloaded the software, I got on 6 meters, and the first contact I made was K9AN. So I worked the F and FT8 as my very first contact. That was pretty cool. That was July 1st, 2017, and my life has not been the same since, so to speak. I did work Joe Taylor on about a year later. So I have the Workdoll Frank Taylor Award. I don't think there's a plaque or certificate, but you know, my dad humor, that I find that funny. The longest distance CUSA to date, when I gave this talk here 5 years ago to this group, it was China. Since then, I worked the VK5 8,200 miles on FT8. That was actually a year ago or so. We've had a lot of openings, which I'll talk about recently, down to ZL and VK, which is really cool. And it's probably not Sporadic-E, but we'll talk about that too. Anyway, so that's some cool stuff that went on. That's probably the highlights of my 6 meter career. Just to finish up my brag tape here, the awards that matter to most people on 6 meters are Workdoll States. I managed to complete that back in 2018. This is a cool story. I had worked Workdoll States on 9 bands, 160 through 10 meters. And I had 49 states worked on 6 meters. I did not have Hawaii. And if you remember, for those of you that have good memories or know Hawaii well, on June 17th or 18th, a day or two after the contact here, the volcano on the Big Island erupted. So I had just worked these guys, and I noticed they didn't do log of the world. They only did paper QSLs. So I thought, oh my God, the volcano that's 4 miles from the station just erupted, and they were predicting even more and evacuating people. I thought, I better get a card before the whole island blows up. So I sent a QSL card, an SASE, and a $20 donation to their radio club. It wasn't a bribe, it was just a donation, and got this in the mail very shortly thereafter. So I took a big sigh of relief, and I managed to get Workdoll States. That's July of 2018 there. So I was really pleased because there's no more states to work. I don't do much 2 meter work. So I'm not going to work any other bands. That's it. So I got my 10 band Workdoll States. I was really happy. Another goal for those of us that work on 6 meters is grids. I've worked as present 859 grids around the world and 816 confirmed. I don't go crazy trying to get them all confirmed. I would go broke trying to, or go crazy. But you know, I'm really pleased I've managed to work over 800 grids on 6 meters in all this time. One award that, how many people don't know what the Fred Fish Award is? Is there anybody that doesn't know? Okay, the Fred Fish Memorial Award. Fred Fish was, I forgot his call, he was a W5, but he passed away about 10, 15 years ago. He was the first ham to work every grid in the contiguous United States. And that includes DMO2, which is right here. You say, well, that's in the ocean. Well, there's San Clemente Island and there's another small island are the only land masses, and the way that they define this award, they're included. So right now, you can't even really get onto San Clemente Island. The Navy runs San Clemente Island and civilians are not allowed. So the only way ham radio operators can get onto San Clemente Island right now is if they're contractors for the Navy or naval, obviously if they're service people, and they have to get permission from the commanding officer that's in charge of this. There was a Austin, I forgot his call sign, KM6 something. Yeah, so there's a contractor who actually got permission and has been on. This used to be one of the most impossible grids to get. We're lucky because if anybody's on there, you can work them with a handheld. I mean, it's 60 miles. It's easy. You don't even need to know. Right. You can go on a boat, but again, you need permission from the Navy, or or you can float around and get seasick out there too. That counts for the grid. But anyway, the point is it's really, really difficult. People on the East Coast, there are a lot of hams that have every grid worked in the lower 48 except for that one. And it's really tough because there's nobody living there. The other one that's almost impossible is EL58. This is at the mouth of the Mississippi River. The only thing that's there were some pilot stations for boats for, I think, petroleum companies, and there's no way to get to it from land. You have to actually leave by boat from like Florida or other parts of Louisiana and sail around and land here. So John NA6L, who's not here tonight, has all of the grids worked except for this one, and we're really trying to get him this one. He's been trying for a lot of years to get this grid. Same for Bud N7CW. So you got two people that are members of this club that have worked every grid except for this one. And the problem is people go there every year or two or three. But of course, when they go there, there's no propagation. So we've had expeditions there and people that have been glued to the radio for 4 or 5 days in a row, and there's just nothing. Yeah. I have a couple others I need. DN77's up in Montana. It's a pretty sparse place. I actually, NA6L had gone on a little roving expedition with his wife and went up here. I actually worked him in DM78. And when he got down to DN77, the band had closed and I didn't work him. So I need that one. This is up in northern Minnesota. That's another one I need. This one's annoying. There's a ham I correspond with frequently. He doesn't have much of a station. He has a wire antenna, but he is on 6 meters a lot. And if we have a good opening, I could work him. EM24 should not be difficult. And then FN53 is another one that there's a little tiny sliver of land. It's either northeastern Massachusetts or southwestern Maine. There's about 6 or 7 hams that actually live there, but not many of them are on 6 meters. So I'm not too worried about those. This is the one that's going to be challenging, but I would like to get it before I possibly move to Colorado next year, because once I move, I have to start all over again, and I really don't want to start all over again. In fact, I don't think I will. So anyway, that's the Fred Fish Award. That's one that a lot of people spend a lot of time on agonizing over.
Thank you.
You'll get there. Okay. Anyway, my major goal, and this is the one that I really want, is DXCC on 6 meters. There are only, I believe, 2 or 3 stations in Southern California, or maybe in all of the West Coast, that have DXCC on 6 meters. Terry N7CW is one of them. In fact, I'm sorry, N6CW, Bud's N7CW. So N6CW gave a presentation about 5 years ago where he talked about trying to get to 100. Now, to Terry's credit, which makes it so much harder than what I'm talking about doing, he did it before any of the digital modes existed. So he did all of it on CW and sideband. That kind of boggles my mind. He did have the advantage of being active when we had some of the solar cycles that were, the solar flux was at 300, and you get F2 openings, it's like getting on 10 meters. So it's not as challenging on from that respect, but without the digital modes, the fact that he was able to work 100 countries and get them confirmed is very impressive. So I'm at 88 worked, maybe 89, I don't know, 88 or 89 worked, and 85 confirmed. 1 or 2 of these was actually this year, so I'm still waiting for confirmation. But this is one that I think I can get, and if I move, I get to continue on that quest. But this is really, for me, my personal goal. Anyway, I've spent way too much time talking about me and my operating, but it just gives you an idea of what's fun about 6 meters, hopefully. Okay, let's segue now very quickly. Things are a lot different than the last time I gave this talk 4 years ago. We're at the top of cycle 25 or near it. The solar flux yesterday was 230. The sunspot cycle, smooth sunspot cycle, was 285. That's pretty impressive. That's good, but it's not good enough. You will not get F2 propagation on 6 meters with those numbers. We need to be considerably higher. Like the solar flux needs to be around 300 or higher to get sustained openings like we see on 10 meters right now. So picture what 10 meters looks like during the day now. Imagine that on 6 meters. That would be awesome. But we need to have a really big bump up in the solar flux before we see that. We are, as Jim mentioned, seeing a lot of openings that are not typical Sporadic-E. I'll talk about Sporadic-E in a moment. South America has been open a ton for the last year, off and on in the afternoons, as has ZL and sometimes VK. ZL's a lot closer than VK. I tend to think of them as being like neighbors, but it's a big, very big distance. I wouldn't want to have to walk it. But in all seriousness, I'm not sure, and I don't know that anybody is sure exactly what's going on with this. Transequatorial propagation, which I think everybody knows about, occurs across the equator. It doesn't have to be straight up and down. It can be at an angle. We, unfortunately, in San Diego live north of nothing. If you draw a line straight south and slightly skewed south from here, you're going to see a lot of water all the way down to the South Pole. So there's not a lot of opportunity for us to even have transequatorial propagation unless it's skewed off at a very severe angle. Sorry, for those of you online, you probably can't see me. I've been wandering. But essentially, what we think is going on with these South American openings, and probably ZLVK, is it's a combination of transequatorial propagation on their end and local areas of higher MUF, maximum usable frequency, on our end that kind of tie together. Because, you know, radio propagation is never that straightforward, at least on 6 meters. You know, we'd love to think your signal leaves, it bounces off the ionosphere, it bounces off the ground, it bounces off the ionosphere. There's more to it than that, and there's different modes. So a lot of times when there were openings on 6 meters, it may be a combination of Sporadic-E, transequatorial propagation. There may be some local areas of high F, you know, where you have some F2 propagation. You can have scatter from aircraft. You can have reflection off of oceans. Both South America and ZLVK have large expanses of ocean between us and them. And so it's very likely what we're seeing are these combinations of TEP, maybe some Sporadic-E or F2 in local areas, and then a lot of reflection off of the ocean water. It's hard to say. I've read a lot of discussions. I've never had anyone come out and say, yes, this is exactly what's happening. A lot of speculation. But the important thing is we've seen a lot of openings. The other thing is we've seen some spotlight openings to Europe and beyond, which I'll mention again in a minute and show you some pictures. In months like March. So March of this year, last month, was great for 6 meters. March is the worst month for Sporadic-E. Statistically, less than 10% of the days would we expect to see any Sporadic-E, much less strong Sporadic-E. And yet a lot of us were working stations. I worked VK9, so that was a new country for me in March. That should not have happened with just Sporadic-E. So there is a lot more going on. And I pulled up some papers, which I reference one later on a slide, and I'm happy to share with you guys, where people have noted that as we get to the peak of a solar cycle like we are now, there is a lot of propagation like this that I'm describing to look for. So definitely want to keep your eyes open even now, because normally I would say we have another month before you should really even waste your time on 6 meters. I will amend that right now to say keep your eyes open on 6 meters if you're interested, because with the solar cycle as high as it is, there's a lot more going on than just Sporadic-E. Yeah. Well, there's a couple. There's some Charlie Echo stations that are on every day, and I can decode them every day, but I've worked them all. And yeah. Anyway, again, you know, this is really interesting. It's something to keep in mind. 3 years from now, 4 years from now, this is all going to go away. Okay. All right, Sporadic-E is what you came for. Sorry, I made you sit through that. This is like a timeshare presentation. It's called sporadic for a reason. Sorry. Sporadic means occurring infrequently. Let me see here. There we go. Occurring at irregular intervals or only in a few places, scattered or isolated. Basically, that just sums it up. It is very hard to know when we're going to get it. It is impossible to predict when we're going to get it, other than certain times a year, and I'll talk about that in a minute. There is a Murphy's Law for everything else for Sporadic-E. There will be poor or no openings during a contest, an expedition to some place you want to go. Guaranteed. If there's something you want to work, it won't be open. I told you I'm from New York. I'm cynical. What can I say? Here's a great example. You remember the Baker Island expedition a couple of years ago? It was like 3 years ago, 4 years ago. Yep. These guys were all excited because they were going to get a 6 meter setup. But things got delayed when they got there, so they decided they would get everything set up for HF, but not 6 meters. And after a day or two, they put up the 6-meter antennas. Guess what happened the first day of the expedition when they were all settled in? We had a massive opening to ZL, and they would have been right in the middle of it all. We could have worked them with 100 watts, but they didn't have their system up. By day 2 or 3, they had it up. We did not have another opening the whole time they were there. That's the sort of thing that will drive you absolutely crazy if you let it. There's another corollary. If you leave the house for any reason, doctor's appointment, whatever, or otherwise able to operate, there will be a huge opening. This is my favorite story to this day. Back on July 22nd, 18, I decided to work on my HF antenna. This was a Sunday. So I tilted the antenna, the tower over, and I started working on it, and it got dark, and I said, crap, I got to go inside. It's dinner time, whatever. I went inside, and it was too late. I'll work on it after work on Monday. Monday morning, I get up, and I've got 5 texts from NA6L saying, get on 6 meters. It's wide open to Europe. So I open up the radio. I have a flex radio, so I leave it on all the time, monitoring several bands. I come in, and there's spots all over Europe. Well, the antenna's laying on the ground. So A, I'm thinking this has got to be a heck of an opening. The antenna's on the ground, and I'm picking up Europe. And B, I can't transmit. We've got dogs, we've got kids. I can't be putting 1,000 watts into an antenna laying on the ground. I might, much less, I don't think I'm going to work anybody. I think I did try. So I watched John and others work all these stations in Europe, ran outside after work on Monday, put the antenna and the tower back up, and guess what? We didn't have another opening all summer. So, again, if I'm more than a little crazy, this is a big part of it. There are a lot of differences between HF and VHF. If the solar cycle is really high for the most part, we're going to have good propagation, other than if there are solar flares and mass ejections. But for the most part, if the solar cycle is high, you're going to have HF propagation every day. That's not necessarily true on VHF. Solar storms, CMEs will wipe out HF propagation usually. We've seen it lately. You get these massive eruptions of the sun, and you turn on 20 meters, and it sounds like everybody is under a heavy blanket or something, if they're on at all. So, HF is very susceptible to this. Openings are typically peaking during the daylight hours, especially as the solar cycle starts to go down. Right now, the solar flux is high enough that 20 meters is pretty much open all day and night, 24/7. 15 can be open, at least late into the night. 10 meters is open, for the entire day and early evening. And you can pretty much predict propagation with the solar flux, time of day. There's all kinds of software that will tell you. You can plot it. It's really easy, and it's very accurate. VHF, on the other hand, especially Sporadic-E, there's no correlation with solar flux or sunspot number other than what I talked about. I mean, there is absolutely, and this is Sporadic-E. Now, if the solar flux gets high enough, we have F2. So that's the same propagation we see on the upper HF bands, like 10 meters. But that's, like I said, the solar flux has to be like 300, and we're nowhere near that yet. So normally, Sporadic-E is completely independent of the solar activity, other than the time of year, which I'll get to. One interesting thing is when we get hit with these solar storms and CMEs and K jumps to 5 or 6, I have noticed we've had some really nice openings for a short time on 6 meters. Say a short time, an hour, 2, 4, not 5 minutes. Something about when they hit the ionosphere and ionize it, I don't know if they're creating areas of like local high MUF or what it is. I don't claim to know, but I have definitely noticed a correlation when we get some of these really large events hitting the planet that we do see an increase in propagation. So whether it's Sporadic-E or not, I don't know, but I'll take it. Openings on 6 meters are much more likely during the daytime, but they can go long at night. So some summers you'll be on at 10 p.m. and you'll be decoding Japan. Very interesting. I'll get into why certain paths are open at certain times of day in a minute, but it's really interesting. There's not this sort of bell curve where as the sun comes up, the propagation increases, solar maximum, noon, whatever, and then down. It's very, very weird as far as time of day, and I have some slides to talk about that. There doesn't seem to be an ability to predict when the openings will occur other than in very general terms. I can tell you what months and what times of day to look, but I can't tell you tomorrow if it's going to be great or awful. And no one else can that I've ever heard about. Well, that's the other thing. We've had summers where on Monday, there's a gangbusters opening to Europe. And on Tuesday, the band is completely dead. Wednesday, there might be a little opening to like the Pacific Northwest. And then the band's completely dead again. The weather patterns haven't changed. The solar flux hasn't changed. Nothing's changed. Something's changed, obviously, but nothing that's really obvious has changed. So it's very, very different, this Sporadic-E from F2. Just keep that in mind. Again, right now, that's a little bit diluted because we're at the high of the solar cycle and we may be seeing some little bits of F2 here and there. So how does this all work? You're all familiar with the ionosphere. We have the D layer. This is where you get a lot of propagation on the low bands like 160 and 80 meters at night. The E layer is where Sporadic-E occurs. This is about, the E layer itself is between about 50 and 150 miles above the Earth's surface. But I think everyone that studies it is in general agreement that the actual Sporadic-E occurs in a smaller band that's like kind of almost see. It's a little dark circle here or line. It's the lower side of the E band, the E layer is where the reflections occur. A typical hop on 6 meters, and the distance that a radio signal hops for either E or F propagation depends not only on the layer height, but it also depends on the frequency. So you can't make a general statement like, you know, every Sporadic-E signal is going to go a certain distance because it depends a lot on frequency and some other things. But generally, each hop is about 600 to 1,000 miles. So, you know, if you're seeing a lot of stations for Colorado and Minnesota, North Dakota, South Dakota, that's a single hop Sporadic-E. When you start seeing Pennsylvania, New Jersey, Virginia, Florida, that's typically double hop Sporadic-E. The problem is, look, New England is a tough place to work as it is, and New England falls kind of in between 2 and 3 hops. So if your signals are all up here and New England's down here, you may not be able to work them. So openings to New England are a lot less frequent because they probably require 2 hops plus either scattering or some other means of propagation of the signal. But anyway, the thing to keep in mind is each hop is about 600 to 1,000 miles. F2 propagation that we're all used to on 10 meters, 12 meters, 15 meters, the F layer is much, much higher. The F layer is up about 150 miles. And so the signals bounce at the same angle, but now that angle then takes them out 1,200, 1,500 miles. I've actually read that some hops on F2, depending on the frequency, can be 2,000 to 3,000 miles. So when F2 occurs, this is where you get these huge openings here. Long distance openings. If we had a really good F2 opening on 6 meters, you should be able to work Europe really easily. And that's, you know, Japan's a great example. Japan will open up a lot at times. And Japan is about 6,000 miles, depending on which island and where we all are located. When you start thinking about that, you go, wow, that's got to be like 6 hops. But you have, again, as I said, this nice reflective body called the Pacific Ocean that may act like a mirror. And so the signals seem to make their way from Japan to the West Coast quite easily at times. And it's really amazing when people on the East Coast are working Japan, and it does happen. So this is important. Now, Sporadic-E clouds, which I'll talk about in a minute, what they are and how they form, think of them as like a little mirror for your radio signal. I mean, I think that's a fair, and Randy, I know you're an RF engineer and antenna engineer, so you can feel free to jump in, but essentially, you have to be at the right angle. If you shoot a signal straight up or at a very steep angle, the signal passes right through the cloud and goes off to Jupiter or wherever. If you shoot at too low an angle, you miss the cloud and they go off to Jupiter or wherever. So it's really important that the clouds are in a location and your signal hits at an angle where there's actually reflection. And that is a big part of the maximum usable frequency. I won't get into all that theory. You can read papers on that. So a lot of things have to coalesce before, including the clouds here, before you're going to get reflection of your signals on 6 meters. So how does Sporadic-E occur? This is pretty much the generally accepted explanation for Sporadic-E. Essentially, what we call Sporadic-E clouds are ions that have all coalesced in an area. So an ion is a charged atom. If you have enough of them, they act as a reflective surface for radio waves. They don't reflect light, but they reflect radio waves. So every day, millions of little meteorites, some of them are you can't see, and some of them could be as big as I don't know, a exercise ball or something, burn up in the atmosphere. These meteorites are mostly made of iron and iron oxides and other metals, different minerals. So when they burn up in the ionosphere, all the component atoms that made them up float around in the atmosphere. So let's just stick with iron. Again, being a chemist, I love this stuff. So iron is the 26th element in the periodic table. It won't be a quiz, I promise. And it's uncharged, like all neutral atoms or elements, it's uncharged. There are 26 positively charged protons in the nucleus, and there's 26 electrons circulating, if you will, around the atom. When enough energy gets put into an atom, it actually knocks electrons out of these valence layers where they're circulating. And again, I'm dumbing this down a little and going with the old Bohr model of the electrons whizzing around the atom. But essentially, you knock the electrons free. Now, each electron has a -1 charge. So when you knock out 3 electrons from an iron atom, you have 3 negative charges here, and what's left is an iron ion with a +3 charge because there are 26 positively charged protons in its core, the nucleus, and only 23 negatively charged electrons circulating to neutralize that. Now, this is really important because these charged ions, if they all coalesce into an area, we call that a Sporadic-E cloud. And those clouds, again, act like a mirror for radio signals. Really important. And what's even more interesting is the weather has a lot to do with these clouds. So here you go, all the definitions. Now, so the question you may ask is, well, what's energy here? The energy is probably 2 things. It's solar radiation to some degree, but that's not enough to explain it all. So there are high-level winds that are in the atmosphere. We're not talking 50,000 feet up. We're talking 50 miles up. These winds are tremendous. I mean, they're going at thousands of miles per hour, and they have tremendous amounts of energy. Think about, I don't know how many people do woodworking, but if you ever have a dust collector in your wood shop, the static electricity it generates is pretty significant. I mean, you can feel, sometimes the hair on your arm will stand up as air is being sucked by your dust collector. Wind, air molecules moving at high speed will actually create static electricity. Well, picture that on a mega scale, like nuclear reactor scale. So the planetary waves, we call them, and gravity waves are these massive winds that are in the upper atmosphere that are imparting tons of energy up there. We don't really think about it, but they're up there. And so all the energy that these add, plus the solar radiation, together can knock these electrons free of the iron atoms and make the ions which we need for Sporadic-E. There is some anecdotal evidence that, severe thunderstorms, like in the Midwest we get in July and June and August, and other severe weather may also contribute to helping form these clouds. The thing that's a little confusing, and I've still not really seen really good explanations, is why it's only May through August. I mean, the solar radiation in late August is pretty high, yet we see very little Sporadic-E in late August. Usually the season's over and dying down by then. So it's a question that I've been asking, and no one's really answered to my satisfaction. But that is this fact that it doesn't occur outside of this very narrow period between end of May and late July makes me think that solar radiation is less important than wind shear. And those of you that are on 6 meters know there's a minor season where there's some Sporadic-E in late December, early January. It's nothing like it is in the summertime, and it's usually pretty short. The openings aren't as intense. But, well, it could be the solstice, but it's actually more in January. And the solstice, of course, is December 21st. So it's interesting. I'm not saying you're wrong. I don't know. But it's really interesting that we have this peak here, and no one's really been able to explain it. There's been a lot of papers on the tilt of the Earth and everything else. Like I said, if somebody can give me a good, plausible explanation, I'll accept it, but I have not seen anything. But the important thing to know is this is what's contributing to these Sporadic-E clouds. They're not just magically appearing. Europe in particular and East Coast have much better propagation. Yeah, there are reasons for that. And that is, the question, for, if you didn't hear it, is why does Europe seem to have so many more and better openings as well as the East Coast? Well, I'm going to talk about the East Coast of the US in a little bit of detail. Excuse me one sec. My wife would disagree, but the worst thing right now would be if I lose my voice. Okay. in all seriousness, there are some reasons. Let me get to the discussion about the US and Europe. Absolutely. Europe has very different propagation than we do on 6 meters. And there are papers out there on that and explanations. But why do we get sporadic? And this is going to get right to your question, Bob. The vorticity theory. People hear this and they're like, is that a sci-fi movie? But actually, this is the underlying basis. No, really, this is the underlying basis for why we see propagation where we do. It doesn't explain when we're going to get it, but it does explain a lot of times where it's going to be. So even if we can't predict when we'll get it, at least we can tell where it's likely to be if it occurs. And here's why. So what's vorticity? Again, get back to the winds. Vorticity is a strong rotation of wind, either counterclockwise or clockwise, or a very strong wind shear. So think of when you're in the plane and you fly over a mountain range and you get a lot of turbulence and the pilot says, oh yeah, we've got turbulence because we're going over the Rockies. That's wind shear. It's mind-boggling if you read papers on how much energy is in wind shear over mountains. I mean, it's enough to like light a small city, that much energy. We don't even think about it because it's dispersed over a large area and it's up there and we don't, it doesn't affect us usually. But all this wind is important. And this gets to your question about, think Rocky Mountains. I'll get to pictures in a minute. Vorticity, there's vorticity horizontally, there's vorticity vertically. I'm not going to get into it. I'm just going to bore everybody even more. But the way that we measure vorticity is we look at the 300 or 500 millibar pressure map. Basically, it's the jet stream and higher. So we're not talking local weather like, there's a small storm cloud passing through. This is large weather that affects regions of the United States. This is the jet stream flow you see on the weather maps. The jet stream is coming down from Canada, and so we have a bubble high pressure here. This is really important. So if you take home anything, this is just a typical weather map. So I didn't annotate this, someone else did, but it's kind of cool. So you've got the jet stream that it's coming down the west coast of the US. It dips down by where we are. Then it comes back up. When you have this typical summertime pattern, it usually means we're sitting under high pressure bubbles. And then you've got all kinds of other forms of vorticity. Wind shear, you'll notice the Rocky Mountains, you get vorticity across the Rockies. All of this stuff is typically going on any given day of the year. So this is important to pay attention to. Not yet, you don't have to study up on this, but you should be paying attention to these vorticity maps, which you can get online, because it explains why some parts of the USA and the world get Sporadic-E all the time or much more frequently, and we don't. So here's your question answered. This is a very typical map of Sporadic-E. For 15 years, this drove me crazy. I would open up ESK Reporter, and I would see this freaking line. This is right where, for those of you that follow grids, where the Delta Mike, Delta November grids are. This is the dividing line, Echo Mike, Echo. So here's Texas right here, if you can't see it. Look at that. I mean, the map is just covered with contacts. Forget this stuff. This is locals hearing each other, all these little dots here. There's basically nothing going on west of kind of Nebraska, West Texas, the Dakotas. Why is that? This we can answer. The jet stream in the summer is usually very strong and usually stays up pretty far north. That means we have high pressure sitting right here. And that's obvious. We have hot, dry weather in San Diego most summers, right? I mean, there are exceptions, but this is typical. So here's this is from a couple of years ago, but here's a great example. This is what the jet stream looks like in the summer. So this puts this bubble here of high pressure. Now, what happens when you have high pressure here and low pressure here? Wind blows this way. So all those ions I mentioned, they get blown away from here and they start coalescing. And then on top of it, you have the Rocky Mountains right here. And so all these ions that are forming on our side of the country are blowing across the Rockies, and then they sink like the air sinks. When you cross the Rockies, it's cooler. And so they start collecting down here. So all these reflective clouds wind up over here. And that's why these folks can all make contacts. Our signals are going up in the air here, and then they're continuing off to Jupiter. It seems trivial or whatever, but it's very, very common. You will see this map, I guarantee you, in the months of June and July. I bet 50% of the days you will see a map that looks something like this. The whole right side of the country is working. Europe, there were, and then of course the ocean's a whole different can of worms. There's all kinds of interesting things that go on, but this gets to your point about why is it the East Coast has all this propagation and we don't. There are some other things that go on that I've read about that are not just that, that contribute to why they have better conditions here, but this is very much something to keep in mind. And this is why you can turn on the radio a lot of days and it's just dead. Well, but these hops, you got to remember, Jim, these hops are 600 to 1,000 miles. So if that were the case, we should still be able to work Texas. Why is it that these guys are getting reflections all over here and we're not getting anything? It's because all the clouds are forming down here in these areas of lower pressure. You'll also notice what typically happens. The jet stream, because of just topography and a lot of other things, typically dives down somewhere around the middle of the country. So what's happening here is you're getting low pressure here, you're getting high pressure here, and that's going to blow everything this way. And I've got a million examples, and I'm going to show you not just with a pretty map here, but I'm going to show you correlations. The other thing is there are planetary waves, these winds I was talking about, that form as the winds blow over. For when the winds hit the Rocky Mountains, they get pushed straight upward. They can't go through the Rockies, so they get diverted upward. Well, gravity works on wind too, because wind is air molecules, right? That's what wind is. It's a bunch of air molecules, oxygen, nitrogen, a little bit of helium, a little bit of carbon dioxide, water. All of those ions, when they reach the top of the Rockies and keep getting pushed this way, they then start to sink. So that generates energy. And again, as I mentioned, it also causes them to coalesce down here. So lots of things are going on that favor this side of the country. If you go to Denver, the propagation on 6 meters is incredibly different than here. It's 1,000 miles away and it's night and day difference. You won't even believe it. That's one of the reasons I want to move to Colorado, by the way. If you want papers, for those of you that are gluttons for punishment, thanks Jim K6OK for this. There's a paper here. There's a lot of papers out there. You can Google them that talk about all of this stuff. And there's a lot of math and other stuff that explains it. If you prefer DX maps to PSK Reporter, same idea. This is a very typical map. It's like, what, did we not pay our taxes here or something? You know, what is going on here? Well, you can see there's obviously Sporadic-E going on in here, and again, Europe's a little different, but New York to Europe is still 2,500 miles. That's several hops. So something has to be going on. Okay, so here's a great example. I just want to show you. These are all maps I have collected over the years. I promise I have not touched in any way. I've not doctored any of these maps. So this would tell you, this is a typical summer day in SoCal. Here's San Diego right there. And then there's California. You notice we're sitting under this bubble of high pressure. And if you then take a look at, oh, I should have put the map up there. I thought I had a map that went with this. The map I showed you on the previous slide, this or this, that goes right with this. And this correlates very nicely to what you saw on I think it's the same day. It's July 26, 18. And I believe that was also July 18. Anyway, I promise you that's what we had. Now, I want to show you some other examples. It's not just that. So here's an example. If you look at these weather maps, and this site's no longer available, they shut it down a couple of years ago, but there's other sites, including the National Weather Service, where you see bright red, yellow, green, orange. These are areas of really high vorticity, meaning there's a lot of wind shear and energy going on. So the areas where you see red and orange and yellow is where you would expect to see Sporadic-E clouds. This map was taken at the exact same time as this weather map. And look where the propagation all is, right where these different areas are. So the smaller areas, you can see there's some stuff going on here. Again, it's not perfect, but it very much correlates. Here's another example. You got this is a weird case. You had high pressure sitting over most of the US here, yet these guys still had propagation on the East Coast. I think it had to do with the fact that there was a lot of vorticity going on up here. But you'll notice, again, correlation between high vorticity and Sporadic-E. I have a million examples. I've actually trimmed this down to not put you to sleep. This was a cool one. The jet stream had gone really far north. So this is the northern Canadian border right here, if you can't see it well on this map. They had a ton of vorticity going on in southern Canada. Look at the propagation paths that were open that day. Isn't that crazy? So it wasn't an east-west thing at that point. It was a north-south thing. But very clearly, that's what's going on. Then there was some stuff along the East Coast, and they had a little bit of an opening there. So again, it's not perfect and it's not foolproof, but if you open up your weather map in the morning and you see this, you might as well go outside and find something else to do, because more than likely you're not going to have Sporadic-E that day in Southern California. Here's an example where we're not under high pressure. There was a lot of vorticity. This jet stream had dipped. It was coming down here. And so most of the US was getting some really inclement weather. There were storms. It was just completely different than we normally see in the summertime. This was June 27th of last year. This is very recently. Excuse me. You'll notice that all this vorticity here over like northern Utah, northern California even, there was definitely a path there. Probably if there had been more stations up in British Columbia, you probably would have seen a lot more here as well. I mean, think of a mirror here. You should have, you know, basically every direction should work. There aren't a lot of hams up here. Once you get past Seattle, there's a few VE7s, but there's basically nobody up here. So there's absolutely a correlation here. And then of course there was another area of really high, this was probably another storm on the East Coast, but you can see what happened here. I think I have one more, maybe two. Here's a great example where we win, they lose. This is where the jet stream dipped over the Pacific and then shot north. And I don't remember when this was, but what you'll see here is all the vorticity is here now, which is very unusual for us normally in the summertime. And guess what? Look where the propagation is. It really should be where the red is. But again, generally, here's the vorticity. We actually benefited. So if you get up in the morning and you check these maps, at least it's going to give you a better sense of what's going on. What does a good day look like? All of these maps I'm going to show you on PSK Reporter, these are my spots. So these are people that heard me that day. I usually do 12 hours, but can't say for sure. I was spotted all over Europe. I probably worked a bunch of them. I was spotted in Japan, probably worked a bunch of them. Basically all of North America and even Central America. Oh, and I worked Alaska. This is Fairbanks up here. That's Anchorage area. That's Fairbanks. So a good day on 6 meters can be a really good day. Don't get me wrong. And there are times we get this. That's a good day on 6 meters. Yeah, I didn't necessarily work all of them, but I'm sure I worked a bunch of them because I was home transmitting, so I'm sure I did. June 19th to 18, we had a nice opening to the north in Japan. Oh, sorry, I messed up my sequencing. That was July of 21. So this was a great one. I know you can't really read this, but this is all Japan. Every one of these stations is calling XC2CQ in Tijuana. And one guy's calling John NA6L right here. There was just a wall of JAs. It had died down by this point. This is at 0037 Zulu, so that's about 5:30 in the afternoon. I have another one. I had a pileup going one day where the whole screen was bright red. I had like 25 JAs calling me on 6 meters. And the signal reports are good, -9, -2, -16, +1. I mean, it was just it looked like 20 meters on a good day. And this does happen. So I just want to, I don't want to be all doom and gloom. Yes, sir. Yep. I don't doubt it. Yeah, I have the JT alert and I have like nine columns and like 4 rows, so 36. Very often it'll just fill up completely and spill off. I mean, that's one cycle. So you got like 36 JAs on one cycle. It's crazy when it opens. In fact, it gets so bad that a lot of us move up to 50323. 50313 is the basic FT8 frequency on 6 meters. So I want to... 323 is usually where people move when things get crazy. This is back for you old timers. This is the old JT65. You can recognize the signal. These are FT8 signals, as you probably all know. Those are JT65 signals. So you're sitting there for 55 seconds going, come on, come on, come on. Don't fade out. Don't fade out. These are 13 seconds at a pop. But if you look here, let's see, Belgium, Netherlands, Germany, Austria, Netherlands. So these were all my decodes and I was working ON4 VT in Belgium. This was way back when. This was that first day, this is 2018, I'm pretty sure, I was just absolutely floored. All these stations started popping up, and I thought, did I accidentally leave the radio on 20 meters last night? And I'm like, no, this is 6 meters. Holy crap. 50276 is the JT65 frequency. I don't think anybody uses that mode anymore. But anyway, the point is, when the band opens, it can really open, and it's exciting and it's cool. So Levi mentioned 100. Here's 90 minutes, 24 QSOs with Japan and 1 with China. And I think I had an annoying VE7 call me in the middle of all this. Yeah, I did. But this was the night of a San Diego DX Club meeting. I couldn't make it, so I stayed home and I worked all these JAs while you guys were here. Well, you were probably at Sizzler. But anyway, so my point being that, and then of course, brace yourself for the onslaught of QSL cards that come in the mail. But anyway, this was my longest QSO to date, 6,600 miles, BA4SI. He gave me a -5. I gave him a -21. Or sorry, I gave him a -5. He gave me a -21. One thing to be aware of is these folks have really high noise levels, especially if they live anywhere near the cities in China, Japan, Korea. Where else do we get a lot of? I'm forgetting one of the other. There's a couple of countries that have a lot of 6-meter ops. They have a really high noise floor. These are distances, by the way. So that's not right. That's a mistake. Japan's not 7,800 miles. But anyway, you can see this is a great night. So this is from 0107 Zulu, so 6 p.m. till 0233. So it's an hour and 26 minutes. You know, and it probably could have worked more, but there's so much QRM. They're all on top of each other. They're all calling you. You're trying to get back. It's just a madhouse, absolutely madhouse. But it's fun. It's like doing a pileup during a contest or a de-expedition. Here's another great one. And again, I apologize. I know it's hard to read. This was June of 2020. These are all my contacts I made in a span of about 3 hours. You got Wales, Ireland, Slovenia, Portugal, France, Hungary, Austria, Italy, Croatia, Denmark, Crete, Scotland. These are all actually completed contacts in my log. Germany, Italy, the Isle of Man. Now, if I told you this on 20, you'd be like, so what, Eric? I can go and do that every day. Big deal. You operate FT8. But on 6 meters in a short span, I mean, wow. This was a really good day. These are the kind of days if you live for. But you're going to have to put up with a lot of disappointing days to get these. They do happen, though. We get a couple a year. Here's another example. We had an opening to Europe. I'll speed this up a little bit. This was really cool, and this was a month ago. Well, the one on the left was this was one of the best openings we've ever had in Europe. I worked all over Scandinavia, Europe. We worked Greece. John and I both NA6L. I think I worked Crete, Greece, and the Dodecanese, which is... They're in a rough spot. They're in a weird spot down here in Southern Europe. And this was a great opening. And you can see not only was Europe open, but look at this. These are my spots. I was getting spotted all over the place. I can't explain this with hops. I mean, if you think about hops, you would expect to see bands every 600 to 1,000 miles. This is just if I blew this up, it would be just a continuum of spots all over the place. I can't explain that at all. Malta. Yep. This blew my mind. So I'm on the radio last month, and I'm decoding a lot. There was a nice opening. You can see people are calling a Lima uniform in Argentina. We had a nice opening in South America here. These are my spots again. I'm calling CQ. I think I was aimed, by the way, at 150 degrees azimuth. All of a sudden, I get a decode from 9 Kilo 2 Golf Sierra. 9 Kilo 2 is Kuwait. Kuwait is in the Middle East, for those of you that don't know it. I can't imagine anyone that doesn't. And I thought, oh, that's a false decode. Digital modes occasionally get confused by noise or glitches, and they give you a false decode. And then the next sequence, I get it again. And the third sequence, I get it again. And then I stop transmitting for a second to spin the beam up towards 010, which I think is the direct path to Kuwait. And I see everybody is calling 9K2GS. So this is not a glitch anymore. And I go, holy shit. He was calling Hotel Kilo 8 Mike Kilo. There was a de-expedition of the Galapagos. He was getting the Galapagos Islands. I don't think the path was this path. I think it was the long path, actually, because all of us that turned our beams this way lost him. When I swung it back down here, he popped back in again. Everybody and their sister was calling. You know, to work 9 Kilo 2 on 6 meters, wow. Well, it lasted for about 5 minutes and then he disappeared. The next day I had another decode of him. This is crazy. I think what happened here is because the solar cycle is getting up there, There probably was an area of very high MUF somewhere. I don't think it was up here though. I think it was actually, like I said, I was aimed down here. And if 010 is the short path, then the long path would be 190. I was aimed at 150. It's close enough. So more than likely, the long path down here is what was happening. There must have been a really high MUF. It probably was F2 propagation, but this is the tantalizing thing about F2. If we get F2, we can probably all work Kuwait. And I have decoded Israel a bunch of times. I haven't worked them yet, but I've had days where I could pick up Israel quite a bit. So it's not unheard of to have Sporadic-E to the Middle East, but this one really blew my mind. That is a long way away. And that's real. In fact, several people emailed him and he said, yeah, I was trying to work HK and I couldn't believe I was hearing him. He goes, I didn't hear a lot of you guys because everyone, like I said, everyone swung their beams up north. You know, we're all trained to think about short path. Yeah, this is crazy. His grid's correct too. It's LL39. Wow. All right. So let's get to the end of the presentation here. So when's the best time of year for ES? I actually have a bunch of these plots. I used to always rely on this one. This is a K1SIX is in Massachusetts. He's one of the premier 6-meter operators and has been for decades. He updates this fairly often. The last update I have is 2017. But what you see here, this is May 11th. This is June 30th. And this is August 15th. This is just this is sort of the probability of an opening. He just plotted, he must have gone and done this by hand, but he essentially plotted the number of, over 35 years, he plotted the number of days in 35 years that this date was open. And what you see is it rises up and peaks. This is right around field day, June 24th, June 25th. So right around the summer solstice is the peak. Okay. Yeah. And field day. I've made a lot of contacts remotely with a laptop from field day, and I will continue to do so. And then what you see is there's another little peak here. And I always thought this was just, kind of noise and averaging and everything. I just recently went for this presentation and analyzed all of mine. I actually did this in Excel. I output my log and this is simply number of QSOs per date. What I see is very, very similar. In fact, I was kind of floored. You have this peak right around June 24th, 25th, and then you see a secondary peak here. Now, in our case, we get out to, this is early August. Right here's the beginning of August. You'll notice it dies out a lot faster for us here. And I've noticed this too. In fact, I usually give this presentation in June or July to this club. I've done it twice, or I've given it to the Fallbrook Club, the 6-shooters, and I usually give it in June or July. And many times people have accused me of being a curse because right after I give this talk, the band closes for the rest of the summer. But actually, I think there's something to be said here. So really for Southern California, these are week numbers, by the way, not days of the week. So this is like May starts right about here. So really it's like mid-May to the end of July is about it. I mean, if you really want me to tell you what these are, I can go look it up. But essentially, you can see it. So, we're not really we're here. We're like late April, maybe here. So Sporadic-E season is just starting to warm up. If you go by his graph here, you're at 5% probability May 11th. And you don't get up to 50% probability until June. So that means every other day you have a statistical probability of an opening. Again, these are just generalizations. Statistics are great, but they don't predict for any given year. They just tell you that the most likely openings are going to be in June and July. Okay, so that's this. If you take home one thing, probably should take home that. What's the best time of day? A little more complicated, but again, pretty predictable. This graph got messed up. I also plotted my QSOs by time of day. They look very much like this. So there's a peak here. This is in UTC. So there's a peak here at about noon, UTC. This is in EA7, so that's his local time zone. And there's another peak around 2100 UTC. That's his local time zone again. WA5IYX, who passed away, published a really nice article in CQ magazine years ago, and he did the same thing. He plotted number of openings versus time of day in the summer. And again, that's about 11 a.m., and that's about 7 p.m., 8 p.m. That's Central Time. He was located in Texas. I'm sorry about this. I don't know what happened on this, but I had another graph. It looks very much like these two. You see a peak around noon, and you see another peak around 7, 8 p.m. So what the heck is going on? Because everybody's seeing peaks at their local noon and local 7 p.m., 8 p.m., 6 p.m., something around there. In the wintertime, the peak tended to be more around 2100, which is interesting. That's the January opening I told you about. Well, what the heck? Does that mean openings are always likely at local times of 1200 and 2100 or 2000? No. What it is it's solar time. So a lot of studies have been done on this, and it turns out that it's the solar time that matters. What's solar time? Solar time is the time at the midpoint between you and the station you're working. So that's what we have to remember. Again, this is just another graph I'm showing you, but this shows you there's a peak around 1200 solar time and another peak. This one's at about 1900 solar time. You know, we can argue is it 1900, 2000, but the point is it's around, 1900, 2000 solar time. So what does that mean? Well, 1200, 1900 are the magic numbers. Now with the East Coast is 3 hours ahead of us. So noon solar time is when it's noon halfway between us and the East Coast. It's 3 hours later, halfway is an hour and a half. So when it's noon in the middle, it's 1:30 p.m. on the East Coast. It's 10:30 a.m. on our side. And that's probably going to be the best opening in the morning. And then at night, it's going to be 5:30 our time, which is going to be about 8:30 p.m. their time. Again, that's a solar time halfway in between, which is 1900 hours. So what you have to be thinking is there's not going to be a time that's best for openings. There's going to be a time that's best for openings to the East Coast. There's going to be a time for Europe. Now, Europe is 9 hours ahead of us, Central Europe, the UK, England, Scotland, that's 8 hours, but 9 hours to most of Europe. 7:30 in the morning is noon solar time, and it's 16:30 Central Europe time. That's their local time. And 14:30 our time, 2:30 in the afternoon, is 23:30, which is 11:30 at night. And you will notice a lot of Europeans will be on at night because they know that time is when they may see openings to the West Coast. Again, this is about 2100, or no, this is 1900, sorry, solar time in between. And then, and you'll notice that most openings to Europe, if I showed you all my logs, most of my contacts with Europe are in the morning, like 8 a.m., 9 a.m., just about. Now, I used to get up at like 6:30, especially when it's summertime and I know the bands are open. But it's very likely that you will not see any openings to Europe after early afternoon. Japan, Caribbean's 4 hours. Again, you can do the math. It's 10 in the morning, 5 in the afternoon. You'll notice a lot of openings to the Caribbean tend to take place at those times. Hawaii is 3 hours earlier than us. So you will often see 1:30 in the afternoon our time is 10:30 in the morning their time, noon in between, or 8:30 at night our time is 5:30 in the afternoon their time, is about 7 p.m. solar time. Again, this is often when I work Hawaii. It's not the only time, but it's the most likely time. So don't take it as an absolute, but just a general time. Japan is actually 16 hours ahead of us. Easier way to think of it is they're 8 hours behind us, but it's tomorrow. So what that means is 2000 PT, 8 p.m., or 4 in the morning their time is solar noon. And oftentimes you see openings in Japan right after dinner. It's very common. A lot of the strongest openings I've ever seen are right after dinner time. The one I showed you with the DX Club meeting, right after dinner. And then the other one, which is 1900 solar time, is 11 in the morning their time tomorrow, and it's 3 in the morning our time. I have not seen, and I leave my radio on, so I wouldn't have been up, but I would have at least decoded. I have not seen any openings at 3 in the morning. The band seems to really shut down. So I would not worry about that too much, but Japan, late afternoon, early evening, that's the time to work Japan and Asia, that side of Asia. Okay. So I'm almost done, by the way. Getting to the end here. So why does Sporadic-E occur on some days but not others? I guess with inflation, it's like a $64 million question now. But anyway, I have not, I would gladly take anybody's opinion as to why it occurs. And again, I could spend hours here. I won't, I promise. Telling you all these anecdotes about how one day was awesome and the next day sucked, or we had a week of crap, and then all of a sudden out of nowhere, this is with no major changes in the weather. Just, I don't know. This is the killer, and this is why you really need to be on the radio or at least monitoring something, because there are going to be days where you would think it got to be an opening today. Yesterday was gangbusters, nothing's changed, and there's nothing. It's why it's called Sporadic-E. But how do you know? So how do we measure? How do we not measure? How do we determine if there are openings that we should be paying attention to? Well, there are still CW beacons. They're in the 50.01 to 50.08 range. For those of you with flex radios or SDRs, you can leave a receiver on that and look for them. There are beacons everywhere from central Northern California to Vail, Colorado is 50.06, I think. There's beacons all over the place. Used to be you could look for TV stations, but unfortunately now with digital, TV is all digital. There's no analog TV to look for. A lot of the old ways that we used to determine if 6 meters was open, you can't use anymore. But certainly the CW beacons is a great example. And this is why I say don't give up on CW, because the 50.080 and up to about 50.100, 105 is all CW, and then 50.100 to 50.200 is all sideband. But do pay attention to this range, because the beacons will tell you, even if you're not near a computer. Here's a beacon map. Sorry, I forgot I put it in here. So here's San Diego down here. You can see there's beacons all over the U.S. And they'll identify, and you can look them up. Most of them will send their call sign and their grid, so the grid will tell you where they are. But even if they don't, you can look them up on QRZ or something. So this is fairly recent. I downloaded this not too long ago. The best way to go, you go to PSK Reporter, you select 6 meters and country of call sign, put your call sign in, and it'll show you all of the lovely, there you go. It'll show you who's working who's hearing who. And then you can go, oh, crap, typical day in Southern California. I'll go outside and mow the lawn or something. Okay. DX maps. I'm not a big fan of DX maps because there are times where the band's wide open and it's blank, and there's times where it's covered in contacts and I turn on the radio and it's dead. I find this to be much more useful, but I don't mean to disparage DX maps. I just don't find it as useful. There are some other maps on this website, the DX map site, that show you things like MUF, the maximum usable frequency, and it will help you see where these Sporadic-E clouds are. You can actually see like these colored squares that he put up there with the MUF, and you can say, oh, there's a cloud right here. So that does help at times. Don't give up on it, but I don't find the actual map all that useful. I don't use Grid Tracker, no. I know what it is. I did use it for a while, but I had problems with it. It doesn't do well when you make a contact with someone that's on a grid line. Yeah, you have to go in there. Anyway, and then Whisper. I know a lot of folks don't really pay much attention to Whisper. This is one of those transmit only modes where you transmit every so often with really low power, and then there's a bunch of monitors and you can plot it. To me, PSK Reporter is better. There are so many stations out there now transmitting on any given day that if there's propagation, you're going to see them on PSK Reporter. But again, it's yet another way to go if the site's down or something like that. If you want to get on and chat, there's this has now become, it used to be ping jockeys. Ping jockeys were for meteor scatter. Ping jockeys was supposed to be for only meteor scatter, and then all these guys like me that were doing FT8 and JT65 got on, and the guy that runs it got really pissed off and tried to throw some people off. So they went and started a VHF chat on Slack. Slack is just an internet chat application. Companies use it so people can, instant message each other. It's not a big deal, but there's a VHF chat board. You have to sign up. It's free. And then there's a lot of folks that are on it. There's sub boards. One board is for people that are on rare grid expeditions. There's another board for people that are in sixth land like us, so we can all whine and commiserate about no propagation, that sort of thing. This ON4KST is a really good board. Again, I'd be glad to share it, but I can send you the presentation so folks will have all these links. This is actually based in Europe, unsurprisingly. This is Belgium. There's different boards for different regions, and when there are openings to Europe, you should get on here because they'll be saying, oh, I just decoded NC6K, or I just worked, so and so. So there's a lot of good information going around. Or you can say, hey, DL1ABC, I'm decoding you, I want to work you, and what you should never do is send somebody a single signal report or say I received your RR73. None of that basically disqualifies a contact, but it's fine to say, I'm seeing you on 6 meter FT8. I really want to work you. Can you look for me? That's perfectly fine. Or thanks for the contact. Once it's done, that's okay too. The thing that I don't get on these very much anymore because I actually know of several hams that achieve things like Fred Fish basically by cheating. they didn't quite finish the contact, but they told the guy on the Slack board, oh, I got your RS-73, or I got your signal report. Well, if he didn't receive you sending RS-73 or 73, and the only way he knows that you got his signal report is by you telling him on the chat board, you basically have cheated. I'm not going to name any calls. They're not local hams. They're not local hams. There's nobody in this club, but I know of at least 2 hams that I saw them do this, and it really pissed me off. You know, a lot of us try to do this the right way. Anyway, this board used to be much more popular. It's mostly California. I haven't been on it in a while, but I don't think there's much activity. Obviously, Google is always your friend, I think. Last 3 slides here. You want to be successful in 6 meters. Get a good receiver. If you can't hear somebody, it's really hard to work them. Get a mass mounted preamp. Try not to blow it up. Not that I ever did that twice. You know, it has to be, if you're running really high power, RF switching is a bad idea. By the time the preamp realizes it's getting fried, it's getting fried. The transistors that are in these preamps are exquisitely sensitive. Even like a watt will burn them to a crisp. So you really need what's called a sequencer that disconnects the preamp or powers down the preamp or switches out of the path before you start transmitting and then waits 10 milliseconds. So please be careful. Don't blow up your preamp like some people I've heard of have done twice. Buy an amplifier. Yes, there are purists who say FT8's a low power mode. It's not. It's a weak signal mode. It's not a low power mode. On 20 meters, I don't think you need 1,000 watts. I don't think you even need 50 watts necessarily. But on 6 meters, you will miss out on a lot if you insist on running 100 watts. I know hams that run 100 watts. The guy in EM24, Levi, you're going to miss out because you may hear this Rarity X in Kuwait, but his noise floor or his antenna may not be nearly as good, and he's not going to hear you at 100 or 50 watts, and you're going to say, oh, I didn't work on them, everybody else did. So, you know, there may be times you don't need it. That's fine. But I guarantee you there'll be times where you'll be happy you had it. I can't tell you how many times I had to crank my amp up to 1,000 watts, 1,100 watts with this big honking antenna I have just to complete a contact. So use it judiciously, but use it. Yeah. Again, a lot of these folks in Europe and Japan have crazy high noise floors. Eastern Europe is a great example. China, a lot of other countries, they have no FCC Part 15, even though nobody follows that anymore. And you know the noise level is like S7 for them. So if your pipsqueak 5-element antenna and 50 watts, they're not going to hear you. Get a good directional antenna. A lot of people say, I've got a stepper with a 6-meter antenna on it. I had the stepper. I had a DB36 with a 36-foot boom with a 6-meter add-on. And I used to switch back and forth when I first put up that 7-element Yagi. There was like a 15 dB difference. There were stations I couldn't even hear on the stepper that were like minus 10 dB on FT8 with the 7-element. So I have nothing against steppers, and they're a great antenna if you can only have one and you need flexibility, but it's not a 6-meter antenna. 4 or 5 elements is plenty. Like I said, I'm not a snob. In retrospect, the 7 elements I have are great, but in reality, a 5-element might have been a better choice for me. You're only losing it maybe a dB of gain, which is nothing. It's a 1/6 of an S unit. It's at 1 dB on the FT8 scale. That's not very much. So unless you're working a lot of stations that are barely at your noise floor that you can decode, I wouldn't worry about it. Yeah.
John, NC6L and Axel is designed for us. We have 4/4.
Mm-hmm.
How it compares to 7. Sure.
Right. Well, I don't believe that will in any way improve your beam width, but what it does is it gives you more directivity. I mean, more rejection, like front to back and stuff. So, and it also gives you better beam width vertically. So you may get a lower takeoff angle with it, but it's okay though. I mean, John has a 4-element, and John NA6L, who's not here tonight, he can, for every brag I made about DX and grids, John's ahead of me on a lot of things. So you don't need a 7-element, but you should get like at least a 4-element beam for 6 meters, because you will really appreciate it. Watch these vorticity maps. Now that I've told you about vorticity, at least pay attention. There are going to be periods of time this summer where we have that hot, dry weather for 3-4 days at a time. Doesn't mean ignore 6 meters and turn off the radio, but don't spend like your whole day sitting there hoping a signal will pop in. There are people I know that do that, and it's just, yeah. Use the spotting networks and the sites I just showed you to know who's on. Send a few CQs, and see on PSK Reporter where you're being decoded. There are many, many people that go to work but have like an SDR, or they leave their radio on and automatically upload spots. So even though you don't work them and they don't call you back, at least you know you're being heard in Mississippi or North Dakota or Kuwait, whatever. Definitely learning FT8 mode. I think at this point I don't need to sell anybody on it. The best you're going to do on CW would be the equivalent of about 15 dB below the noise floor. And that translates to, and that's a young guy like Levi, not like an old guy like me or a lot of us that, I have pretty good hearing, but I don't know that I can hear even this far down anymore. So you're going to gain 10 dB with FT8 over CW. Now, if the band's wide open and it's a contest, by all means, get on CW. But, definitely keep this arrow in your quiver, as they say. And sideband's even less sensitive, of course, than CW and FT8. Please watch your signal quality on there. One ugly signal being put into a power amplifier can wipe out the entire band for half a second. I mean, I can't even begin to tell you what I've seen out there. Yeah. Yeah. But when all those spurs get amplified, it's even worse. Yeah, you're absolutely right. If you do get bored, by the way, every morning, so I talked about meteorites hitting the planet. Every morning, there are thousands, if not millions, of tiny meteorites that hit the ionosphere. When they first hit the ionosphere and burn up, they generate ionization. And guess what? Remember sporadic-E clouds, ions? When these little meteorites hit the ionosphere and burn up, they form a very small patch of ions for a few seconds. There's a mode called MSK 144 that actually can pick up these really short bursts called pings and decode them. So any morning, if you go to 50260, point your antenna maybe 45 degrees from here. So that covers kind of north, northeast, east. You're going to pick up a lot of signals from stations all the way up to Seattle. The range of, because of where they burn up and where you see this ionization, the range is usually limited. I think the generally accepted max is 1,200 miles. I've not had a lot of contacts above 1,000 miles, but you can get on and work most of the western states every morning with meteor scatter. So even if there's no sporadic-E, any time of the year, the worst months of the year for sporadic-E, you can use meteor scatter because it has to do with the rotation of the Earth. And I've tried to picture it, but the Earth is rotating into the sun. And what happens is the solar radiation combined with the meteorites burning up together forms these ion patches. And so there's very little, like if you try to run meteor scatter at 8 o'clock at night, you'll get pings. Now, the exception, of course, is when we have all these meteor showers. And there's some really significant meteor showers. You'll see people at 2 in the morning making contacts. But it's not like sporadic-E where your PSK reporter is going to show the whole country. A lot of times you get reflections and you'll see a band or something where you're being heard. But if you're bored and you really want to get on, or maybe you need a grid that's within 1,100 miles, do it. I mean, I've made a lot of good contacts here, and I've picked up some grids I needed that way. I'm at the point now where, other than DN77, every grid I need is well outside of meteor range. But that doesn't mean you shouldn't try it. It's a lot of fun. In fact, on that Slack board I mentioned, which you can get access to, there's a whole board that's dedicated to this, and people will. Yeah, 5 a.m., 5:15 in the morning, you'll notice it'll really start to pick up. Like I'll sometimes go to bed because I'm a night guy. So I'll be up at midnight, 12:30. It's all I can do to get out of bed at 7 or 6:30. I'll put the radio on 50260 and go to bed, knowing there's not going to be anything anywhere else. And then I get up at 8 o'clock or 7:30, and there's 30 decodes from 5 o'clock in the morning. It actually seems to peak at sunrise. And then it drops a little bit and then it fades over the day. So, but definitely check this out. This is fun. Meteor scatter is fun. I mean, for years before FT8, this was one of the, people would do CW, and you can actually, each meteorite burning up, at least the bigger ones, will leave enough of an ion trail that you could quickly send your call or send a 599 or something like that. I mean, the ionization persists for 3, 5, 8 seconds. It's really cool. And sometimes you get bigger meteorites, you get what's called a burn. In fact, if you watch the graph of the signals, you'll see a big red blob and then it'll fade out. And it's the ion trail as it fades. Because what happens is ions are unstable because they're charged and they're missing electrons. At least iron atoms are missing electrons. So as soon as another molecule comes by with ions, they'll neutralize, another molecule comes by, it'll neutralize the ions. So free ions don't last a long time, at least at the lower levels like here. It's amazing to me sometimes sporadic openings can last hours. So you've got these very unstable ions that are floating around in the ionosphere, and they're actually, just hanging out up there as, positively charged species. It's very weird. I mean, any other molecule, if you were to drop like, water in there, it would react with these iron ions. So it's really interesting. Anyway, we're just about done. I do have some requests. So I felt obligated to put this up because there's a lot of really bad behavior going on 6 meters. Please listen more than you transmit. It's perfectly fine to send a bunch of CQs, 5 minutes, even 10 minutes, and then look at PSK Reporter and go, oh, here's where I'm being heard. That's fine. Make sure you have a clean signal. Not only are you helping other people, you're helping yourself. If you run an amplifier and you run a really dirty signal into it, you may fry your amp. And that was the first thing I thought was happening when I was burning up my solid state amps, till I realized that was the only amp I ever burned up. But make sure you have a clean signal. There is a rule. It's not followed as much as it should be. It's followed a lot with Japan and Asia. If you're beaming east and CQing, you should be on the odd sequences, meaning the ones that start at 15 seconds past the minute and 45 seconds past the minute. If you're going west like Japan, Hawaii, you should be CQing on the even sequences, which start at the top of the minute and 30 seconds. Otherwise, what happens is you're on and you're trying to hear this weak station on the second sequence. And then dumb old NC6K gets on 1500 watts and starts sending CQ 200 hertz from this weak station. And guess what? It's gone. It's hard enough, like Mike and Gail and I live 3 miles apart in Poway. Back when NN3V and NN6R and W6HDG all lived in Poway and K1ROA, and we were all on 6 meters. I can guarantee you when any one of us were transmitting, nobody else was receiving anything but us. It will desense your receiver, guaranteed. And, especially if I can remember one time I got on and I think it was Charlie, NN3V. He was aimed right at me and he transmitted and the whole waterfall just went red. I was like, I guess I'm done now. So, again, if someone's calling on an off cycle and you need to work them and they're in some rare grid or DX, yeah, you're going to have to call in whatever sequence, they're not on. But if you're calling CQ, I try to, make my contact and get off of the wrong sequence so that I don't, QRM everybody else. If you live near other hams on 6 meters, you'll know what I'm talking about. It can absolutely obliterate any signal that's not like S7, and that's no fun. And of course, common sense. If everybody that's near you is on one cycle, get on the same cycle. Please try to use CW and sideband. There is more than FT8, and that's especially true during contests. And don't tell me there's FM, because then I'm going to really cringe. Please don't CQ. And there are a few stations in San Diego County. I'm not going to name them, but they annoy the crap out of me. They will get on and CQ for 30, 40 minutes at a time. It's like, give up, dude. You've got your... And they are all men in this case, but I mean, call for 5 minutes, let your amp cool down, see where you're being heard, wait 15 minutes, listen, maybe someone will call you back. And then again, if you CQ endlessly on one sequence and then all of a sudden some distant station, the path opens up and they start calling on the same sequence, how are you going to know? You're transmitting blindly for a half an hour. You're going to miss them. So please, be thoughtful. Some of the same stations, there can be an opening to some rare far part of the world. And I call CQ and some guy 8 miles from me calls me back. And I've worked him 18 times over the last 4 years. If you really want to piss me off and have me ignore you, that's a good way to do it. And I've seen this way too often. This is not 80 meters. If there's an opening, locals should not be working locals. You can always work somebody 50 miles away, 100 miles away. But yeah, don't do that. Said that already. And there's a lot of this going on too. And there's 1 or 2 stations again here. They will hear that, P5 KIM is on 6 meters. Okay, there's no opening. They'll start calling blindly. P5 KIM, and I won't say the call sign, but there's 2 of them in particular. And they'll start blindly calling, even though they've never heard the other station, in the hope that maybe that station will hear them and call back. Well, if you can't hear them, they can't hear you. So you're just throwing a lot of wasted energy into and QRMing people. I mean, once in a rare while, if you know someone's out there and you think maybe they can hear me, I'm running more power than them. But again, if you can't hear them, you can't work them. So just don't do that, please. All right.
Don't work the middle of band.
Yeah.
so that the other guy can move the other side.
So thanks, Mike. And it's not just you. I've done it. Everyone's done it. So the point here is well, I was in that case, but I'll let you off the hook. So here's the thing, the people are, and this is one of the bad things about FT8. The bandwidth of a SDR is really wide, but a lot of people that still have, non-SDR radios, your audio bandwidth is maybe 3,500 hertz, give or take. We can argue what it is, but let's call it 3,500 hertz. So you can put your signal anywhere in that audio passband between, say, 100 hertz and 3,500 hertz. If you're right in the middle and there's other stations fairly nearby, you're going to just wipe everybody out on both sides because your signal peaks in the center. So if you know that like a lot of your neighbors are also on, I usually try to go up as high as I can. That does two things. One is it leaves some quiet space down at the bottom for, them to hear other stations and work. And I've also noticed that if there are going to be spurs or things, if Mike transmits with 500 watts or I transmit with 1,000 watts, we're so close, or Gail, sorry, I didn't mean to leave you out, Gail. Just by the nature of being close, even though the sidebands and the spurs are suppressed per FCC requirements, we're still so close that they're still enough to desense your radio. So if I'm dead smack in the middle, I've just wiped out the Mike's and Gail's entire audio passband. Whereas if I move up high enough, at least I give them some space to work too. So it's really just common sense and courtesy. It does get challenging at times when there are openings. This band has become so popular. There'll be 30 local stations, DM12, DM13. There are a lot of hams, and there are a lot of hams with amplifiers and antennas for 6 meters now. So anyway, that's it. Thank you. I'm sorry if I ran a bit late, but get out there, make some contacts. I hope to see you on 6 meters. Happy to answer any other questions, and thanks for your time and patience.
WA6HXM.
Yeah, I don't think I could do this again. Yeah, sure, of course.
WA6HXM.
There seems to be sometimes a very local situation where we're getting some stations that maybe somebody 20 or 30 miles away aren't hearing, and vice versa. How do you attribute that?
So just in case anyone didn't hear, the question was, why is it? So this is a great example. NA6L is on Point Loma, and he's up above the water. I'm in Poway, right at the foot of the mountains, same as Mike and Gal. There were times where John will hear a station and work him, and I'm like, I see him working. I'm going to go, are you hearing this guy? He goes, yeah, he's -8. He's really strong. Well, if you picture these, if you have really small Sporadic-E clouds and you start drawing, straight line to the cloud and then down, it doesn't take much sometimes. These openings can be very knife-edged, where it only takes 20 or 30 miles. I think John and I figured out we're 35 miles apart from Point Loma to Poway. So oftentimes that will happen. One of the grids I still need for Fred Fish, the EM24, was on last year during a VHF contest. I think Levi worked him. Larry Shapiro, who is going to be a member soon, hopefully K6RO, is in Fallbrook. He worked him. I never decoded him once. And EM24 is like due east of us. And when I looked at all the people that worked him, Levi's north of me. You're in San Marcos? Vista. Larry's in Fallbrook. All the people that worked him were 10 miles plus north of me. Nobody south of about the 78 worked EM24, and that included me. It was just this like knife edge, and I presume it was just if you looked at the path, I just was outside of the reflection.
The other quick question is, I got into ham radio during the peak in 59 and 60. And my mentors, my Elmers, were on 6 meter AM. Yeah. During those days when there was a lot of solar activity, and I was in upstate New York, so a lot of aurora, they would all point their antennas due north, and they'd hear all the echoes coming from all over the place. Yeah. Have you seen any of that with FT8?
I have not. So the question's around auroras. Now, unlike HF, where aurora is bad, we don't want auroras. You go to Alaska, try to work a contest, and there's auroras, you might as well go outside and watch the northern lights. But VHF, like I said, so we get these coronal mass ejections and K gets blasted up to 5 or 6. all of a sudden there's an opening. There's something about these large inputs of energy. Again, if you think about it, we need ions. To get ions, you need iron atoms, which are always floating around the atmosphere from meteorites, but you need energy getting in there to knock the electrons out so they can get ionized, charged, and float around. So things like auroras are typically when there's so much solar radiation of a certain frequency, energy, that you get ionization. So it's not surprising. Now, we're too far south. Has anyone that lives in San Diego, while you were in San Diego, seen an aurora? I don't think they ever get this far south. It's like snow where we're just, really? I was born 6 years later, sorry. No, it's serious. I'm old too, so I can make fun. No, seriously, we don't get auroras down here. So now Sporadic-E, everything I've told you about that I've learned about Sporadic-E pertains to what they call mid-latitude. So the lower 48, southern Canada, Central America. For north of, say, the US-Canada border, more than a few hundred miles, totally different beast, everything about it. They have very little Sporadic-E. It does occasionally happen, and we've all worked Alaska that are on a lot. I've worked as far as Fairbanks, which is cool. I have a friend that lives there. I have two friends that live there. I've worked up there. And then south near the equator, whole other set of rules. So there's a whole different set of rules there. But as far as the aurora goes, anything that's why I was saying, like, even massive energy, when they had those really intense thunderstorms, either last summer or the summer before, I was seeing openings to like Tennessee, Kentucky, I'm trying to pick West Virginia, because there was all this energy in the atmosphere, and presumably that was causing, the clouds to form. Sometimes, yeah. Again, it's just a matter of energy, and it has to be the right, energy is all different. Light energy is visible, and there's ultraviolet and infrared. So you have to have the right frequencies, not the electron out, the right intensity. It's a lot of energy to ionize, but because they're floating up there and there's nothing to quench them, normally, like if I could have a bucket of iron ions, and I pour them out on the floor, they would immediately cause the floor to burst into fire, and they'd be reacting with everything. The only reason they can exist up there is think about 50 miles up, there's very little air, meaning there are very few other molecules. Because oxygen is a very reactive molecule, even O2 that we breathe in is very reactive. So if there's too much air around, ions can't form because they'll immediately quench. So that's why you have to look way, way, way up where there's very little air as well. Sorry, question? Next question.
This is pretty fringy, but have you heard of HARP? H. Right.
Well, I'm loud. If you can't hear me, the Zoomers can't hear me. Okay, Zoomer. All right. Another dad joke. Sorry. Okay. Yeah. So HARP. Well, I mean, I always wanted to see if I could get my 6 meter set up and plug it into HARP. Yeah, it would be great if you could put out an effective radiated power of 10 million watts or so. You could probably, there's always been this theory. It was really funny. We laugh, but about 10 years ago, a few hams got on and said, what if we all transmitted like full legal limit power into these directional antennas, all aimed at the same spot at once? Could we create our own ionization? You're not even in the ballpark. Think about a lightning bolt. A lightning bolt's 1 million volts, 10 million volts. I have no idea how much current, but it's in the thousands, if not millions of amps. Do the math on how many watts that is. 10 to the 6 times 10 to the 6, 10 to the 12, 10 to the 12th watts. Take a lot of hams to put out 10 to the 12th watts. So there's some Italian stations that may run about that much power, but we won't go there. Other questions? They're really, but in all seriousness, I mean, we really, we don't know the answers to some of these things, so why not try? Anyway, any other questions? Anybody online needs to ask a question? Let me get out of
WA6HXM.
Yeah, go ahead.
My name is Peter. My call is Whiskey Alpha 6 Hotel X-Ray Mexico.
Yeah, I know you, Peter. How you doing?
I consider myself one of the pioneers of the 6 meter DX, and I want to tell you about ground waves. In the early 60s, I bought a house on top of Palos Verdes near the W6AM Rhombic farm, and I put up a 54-foot Roan tower, and on top of that, I put a chrome moly mast and extended 20 feet above the tower. So on that, I put an 8-element homebrew, wide space, 6 meter Yagi, tuned to 50.110. My signal was generated from a heat tip SB110, like you said. In those days, either guys had Telecrafters transmitters and transverters, or they used SB110s. It was very common. I had a 4-1000 amplifier that I ran, and arguably I was the loudest station out of California. In any case, on ground wave, I used to work W7FN up on Mercer Island every weekend of the year that we were both home, regardless of the time, the weather, which just goes to show that power and elevation and good antennas does work. Ground wave is amazing. I used to easily work in Anchorage when somebody was there, and of course, Reno, Vegas, Phoenix, Scottsdale, all of that. Anyway, I just thought I'd let you know that that ground wave, I believe, is still there. Brian has my application for membership in the San Diego DX Club, and hopefully I will be approved one of these days. Larry Shapiro, by the way, is a good friend of mine from San Diego, or from Southern Cal DX Club. I'm a member of Southern Cal DX Club, Northern Cal DX Club, and Southern Cal Contest Club, so along with others. Brian wanted me to introduce myself and talk a little bit about myself, and I'm not going to do that because of the hour. If you want to know something more about me, look up my webpage. It's pretty accurate on QRZ, and I hope that the board will one of these days look favorably on my application for membership. I could tell you about trans-equatorial, all kinds of propagation I've done over the years. Unfortunately, I took down my 6-meter antenna from pressure from the guys in the DX Club. They told me, hey, a real ham has a 204 BA up and is on 20 meters. So I did that, and I have not been very active on 6 since then. I've got 6 meters, 100 watts in my mobile with a horizontal antenna. That's about it. But we're building a contest station down here in Ramona, and I will have a kilowatt, and I'll be back on 6, probably with a high gain 6-element beam, something like that. So anyway, hey, your presentation was outstanding. I'm sure you know Chip Engel, N6CA. He's a real student of 6 meters and VHF propagation, and I've learned an awful lot about him. Thank you for the time, and your presentation was outstanding, outstanding, and I can't argue with anything you said. This is WA6HXM.
All right, Peter, thank you. I appreciate the kind words, and glad you enjoyed it. Anything else online, anyone locally? Great. Well, thank you so much, and hopefully I'll see you on 6 meters, everybody.
Eric, thanks very much. That was a real tour de force on 6 meters. I just had one quick question. Operational, you put out close to 15 kilowatts of ERP. Have you worked any EME on 6 meters?
That's a really good question. So I'll just
you have a couple degrees of.
So that's a point I didn't address here, but I should have probably. So you can work EME without an EME setup. Obviously, you can't work it all the time, but when the fairly low on the horizon, if you have a Yagi on tower or a mountain tower, you can where the moon is, and with these weak signal modes now, you can actually make contact. In fact, NA6L was talking to me about possibly trying to get that as one way to work EL58, the grid at the mountain of Mississippi I mentioned. It's about 1,800 miles. And with EME, it doesn't matter. As long as the signal can hit the moon and be received, you could even possibly do it. The problem is not us. We can all, with our home stations, generate a lot of power. It's that when you're on a boat in the middle of the Mississippi River, or you're on a spit of land and you got there by boat, you probably don't have a full, 1,500 watt amplifier, enough power to run your generator, and a 7-element antenna. These guys are going out there with 500 watt amp, solid state amps, and maybe a portable 3-element connector. So EME is definitely doable on 6 meters for terrestrial stations that aren't set up for it, but only under the right, you have to pay attention where the moon is, and a lot of people are encouraging us all hams to try it at least. So that's a good point. I'll have to try it out one of these days But if any of you do it, please let me know how it worked out.
Yeah, I saw your antenna had a fair amount of vertical beam width, and
Yeah,
when it's on the horizon, both moonrise and moonset, you could do it, and
yeah.
What's the calling frequency for EME?
Well, no, it's by mode. So EME you got to do something like meteor scatter. I mean, I don't think the problem with EME is, the moon is moving at a, it doesn't look like it's moving very fast, but it's moving very fast with regard to the ground. And, no, the moon's circular. I guess last I looked. You're not one of those guys who thinks the sun.
No, okay.
Let's check. No, it's a good point. I mean, it's not quite like working a satellite where there's like massive Doppler, but you do have to make sure that you keep your beam pointed basically right at the moon. I mean, it's a very small satellite that's like 186,000 miles away. So there's not a lot of play, but you're absolutely right.
yeah.
I would love to try it. I've thought about it, but not super. I haven't spent a lot of rates, but it's something that if anyone manages to make it work, please let me know. I would really love to hear it. I have some eyeball QSO cards. If anybody wants my contact info, happy to trade thoughts over the internet, over mail, whatever, on commuters. Feel free to grab it.
I was a navigator on the U.S. Navy Star that's stationed out in New Orleans. It's 99 nautical miles to that southwest point you're talking about. There happens to be a national park there. It's a old fort that's sinking. So there's your hint. If you could get with a national park and the local hams there in New Orleans and set up some kind of field day from that point, that could get you your extra grid.
That fort is in EL 15. The problem is EL 58 used to have more land, but forgive me, I'm not trying to talk politics. Climate change and rising sea levels, there are grids now that used to be land grids that are still required for fish that are completely underwater. You need to be either on a boat or standing knee deep in water to be efficiently, and you need to, nowadays with GPS, you need the GPS, you gotta take a picture of it with your radio and prove that you're in that grid. But thank you for sharing that. I'm just saying, this is the problem, that grid is disappearing. There is a pilot station with power and everything. I mean, it's a big, when I say a pilot station, it's huge. I mean, it's like a 2-story concrete
lighthouse. Yeah.
Problem is, they allow people from the Google satellite picture. It looks like the roof is nice and flat. It would be awesome if they let you on the roof. And like in their 20 they have it.
Well, if you're really motivated and look on a chart and see if there's an oil platform, and if there's an oil platform there, contact that company. They have helicopter flights at least once a week to that platform.
Yeah. There's a lot of hands that need a lot, and there's been, a lot of discussion about it. Thank you. There's another grid that's very difficult. Echolina 84.
The other two.
I think it's Tortuga.
Dry Tortuga.
Oh, so we just have.
That's another one that's disappearing or as land, and the entire group will move into the water. So again, as Jim mentioned, you can be on a boat, and as long as you have a GPS to prove you're in that. One of the things about you can work a station in Canada. A lot of the grids that are along the Canadian border, or Mexico for that matter, are split. The grid is split between the two countries. You're not required to work a U.S. station in every grid. You have to just work a station. So I have 1 or 2 grids where I've either worked a Canadian or a Mexican station to get that grid, like Delta Lima 88's on the Mexican border. That's one you need. There's a couple of Delta Lima grids. You can work any station in any country in that grid, and it still counts for grid fish. And the same thing is true for you can be in a boat on the water, on an oil rig. Suppose you can, I don't know if you can be like in a helicopter floating above it. I don't care what it. But I just wanted to point out, if you have to work a bit directly against some of the Fox and River grids, there's a lot of grids that are more in Ontario than they are in New York, for example. You can work BEs and yeah. All right, hey, thanks, guys. Thank you.
We're going to do a quick roundtable, and then I think we'll have our drawing and adjourn. So let's start with Jim.
Hi, Jim, K6ZH. We were in Visalia with a number of you, and this year was the first ever 6-meter dinner. which Joan and I went to, and 6GP arranged it, and it was fun. We had a chance to kind of go round table, kind of mini version of what we did tonight, and talk about things. Next weekend, we're going up to our place in Goldfield. We'll be out on a 7QP contest next weekend. If any of you still need grid DM17, you know, I've worked quite a few of you over the years, and a lot of what Eric said tonight is germane. I've done probably more meteor scatter to here than E-skip. And it is a perfect, yeah, and I've done it on CW if you can't stand to do FT8. So anyway, I'm going, if as far as I know, this is going to come to pass. I am going to Croatia for the CQWPX contest at the end of May, CW contest. I'll be on with the Multi 9A1A. If any of you need Croatia, well, first of all, if you need Croatia, you know, 91A is the station you want to work. I will be on probably at least one day prior with my own call, 9A/K6ZH. So I'll be happy to make a scat or whatever with any of you that need that. I guess that's, thank you very much, Eric, because a lot of what, we have a lot of common shared experiences with this.
Mike, NA6MB. Do a little bit of 6 meters. I probably have about 15 states in Mexico. It's a fun band, mostly FT8. I don't think I've ever made a SSB contact on 6, so except locally. It's a fun band. Other things, last Friday I just said, let's see what's on. So I turned it on and I worked 3 of the D expeditions that were on with Astral Island, Easter Island, and Chad. We're all on, all 3 on a couple different bands, a couple different modes. SSB, finally got the microphone warmed up after a while. I've been working a lot of FT8, so it was good to get back on the voice mode. And the K4 I won last year at the DX convention, and the KPA 1500 work really well together. And opposed to Eric, I have a DB18 stepper, and I have never had a problem with it. So we'll keep that up.
Well, thank you. And just echoing what Mike said, and just a few new ones. St. Vincent, Malawi. Actually, Greenland was new for me, and there's a few more here, but I won't bore you. And Visalia was a lot of work being the program chair, but I'm done. I will never do that again. But if you were there and you liked the programs, thank you.
Very extremely well done. Just the right time.
But here at E6PH, likewise on the local, the D expeditions, I got my Chad on 15 meters today. Really surprised I got it with 100 watts on 15 meters on a wire. But definitely they were booming in this afternoon. So I texted Tom. I don't think you heard them, but they were booming into me. So that was fun getting Chad. But I also got the Easter Island and the Austral Islands. But and Eric, like you say, the 6 meters, it used to be in field day. I'm the VHF guy, and 6 meters for years it was all about sideband and a little CW. Now, nada. 6 meters on field day is all FT8 all the time. There's nobody on phone or CW at all. You just won't find them. So
yeah, it's a mixed blessing. By the way, just quickly, 86 and Easter Island are also on 6 meters. I don't know if 86 is gone now, but they were on 6 meters, and the Easter Island is on 6 meters. That's a very workable path if there's any kind of opening. So do point your antenna south, regardless of what antennas you're using. You may be able to work Easter Island on 6 meters.
Rob WA3IHV. I don't really work 6 meters, although my stepper will work it. Just a comment about Terry N6CW. I think it took him 30 years or thereabouts to get DXCC on sideband and CW. So FT8 has changed has changed the magic band quite a bit.
Tom K7YMG. This was kind of an interesting topic because 2 or 3 days ago there was an opening to New Zealand, and I worked 2 stations, which I've never worked anybody on 6 meters, and all I've got is a vertical in the backyard. But I've been working the DX stations. The one I'm trying to get, and I think I've worked him once now, is the Bhutan station. That one's a little difficult. It's kind of like working Kazakhstan or something, you know, it's in similar area.
700 miles.
Yeah.
Yeah, and they're in a bad spot. They're so far. I mean, I think their heading's like 310.
Yeah, something like that. Anyway, so things are going okay.
Steve, K6RSH. I'm having a pretty good time on Gray Line, but I tried to get India and Kazakhstan again this morning, and I can't get them. You know, there's 5 minutes. And if you miss that 5 minutes, forget it. So I got a question, and I think this may be a newbie question. Once in a while, I hit a station to get it, and it comes back immediately, Roger, Roger, 73s. Are they just flipping me the bird or what?
Pretty much.
Huh?
They'd send R and signal report, then you'd send RRR, then they'd send 73 and you'd send 73. So by sending RR 73 after the second signal report, you're done at that point.
I didn't get a second. I didn't even get a signal report.
Well, then somebody.
Not their law.
That's what I figured.
Jerry W6K, and excuse me, the first time I tried 6 was on a Heathkit sixer, if you remember the lunchbox. And so wide open, 5 watts. Yeah, right.
Danny, WB6FWS. Really not much of a report. I had a lot of computer problems, and my buddy here helped me out of it. So I got my data back, but I lost my complete log. And fortunately, we were able to retrieve it. So thank the Lord for Logbook of the World as well.
Brian KN6MJK. Been working some 10 meter. I was chasing Gail the other night, and she wouldn't answer me. I think she was anyway. But I was able to work in the morning, Europe on 10 meters. In the afternoon, I went to South America. Then I think it was about 6 p.m. I went over to 20 meters, and Israel popped up for me. I don't have Israel, and the poor guy. This is FT8, and he kept telling me I was a -13. He was a -20 and 24 for me, and we went back and forth, and back. We could not complete that contact, and I need him. So I wanted to see if he moved up later on in the night to 40, but he didn't. So, and tonight we have up on Zoom up there's Peter. You heard him talking earlier. Peter is applied to be a member, and so this is his first meeting. He's WA6HXM, been in radio a lot of years. He went up with us to Isaiah, had a great time. I think he went to the 6-shooters thing, didn't he? Yeah, I think he did. And doing radio a lot of time. We had a lot of good talk on the way up and the way back. So this is his first meeting. He's got to do one more, and then we'll vote on bringing Peter in. But long time radio guy there. So probably longer than I've been alive. So anyway, all right. We'll come to you in a little bit, Peter.
Okay.
N6PTF, this is Donald. Don't really have anything to report this time.
KIS6 IT, I'm Mark. Enjoying the 15 meters in the mornings just after daybreak, and there was talked to 3 Israel stations this morning. It's been really a nice openings.
Levi K6J. This was my first meeting since pre-COVID, since I was still coming with WN6K. So he's a SK since then, but good to see some familiar faces. I've just been contesting all over the place, so I don't know. Look, on occasion. Yeah, I just got, I guess to that note, I guess I just got results for sweepstakes sideband from last year, and I just won that. So I'm very, very proud of that. So, but yeah, I don't know. A lot has happened, but not much to report.
Eric, NC6K, other than 6 meters, I've been doing a lot of contesting. I just got my plaque from 2022. I managed to win the Southwestern Division low power for sweepstakes CW. I'm really proud. I finally made it to 300 DXCC work. I'm at 302. I think I'm at 298 confirmed. That's been a long time coming. I didn't even work DXCC until I'd been a ham for like 20 years. So very slowly making it up the food chain. I don't know if I'll ever make honor roll, but it's been a lot of fun.
Randy, KQ6RS, kind of in addition to playing with balloons and buoys and things like that, I just fired up the sideband 20 meters yesterday evening around 8 p.m. and in probably like an hour to Ukraine, Lithuania, Italy, Romania, European Russia, and the Madeira Island. This is on sideband. So it was just amazing. So I got to spend more time in the air now that we're at the peak cycle. I don't want to let it go by again.
Wonderful. Hi, Steve, KE6FE. I've been pretty much consumed by all of the D expeditions. I've worked Chad on 7 bands, FT8, which I wouldn't been able to do on phone or CW just because the pileups have been insane. I also worked Easter Island on 30 meters and the Austral on 30. The disappointing thing about both the Astral the expedition as well as Easter Island is they're not working any of the either 80 or 160. The other frustrating thing is Chad is not doing any of the live online logs. So it's a crapshoot as to whether I've been taking, and again, this is one of the beauties of FT8, screenshots of everything, because that's the only way you can really be sure. But as a bonus, I also worked Osagawara, which was on yesterday, and that's a new one for me as well. So all is great. And yeah. Yeah.
Howard, KY6LA. I just realized what an old timer I became. We got started on 6 meters by buying old highway patrol radios. And they were when I was doing first got my first one was a 47 megahertz AM radio for the trunk of the car, and it took up the entire trunk. And what we could do when we knew 6 meters was open was channel 2 was going crazy. And you'd wait to channel 2 and then out to the car, 6 meters is open. Because that's where the only place I had a 6 meter rig that actually worked. And then in the 60s, we got highway patrol FM radios because the AM radios had been obsoleted. And they were again about 15, 20 bucks. And that's so I start feeling how old I am, at which point I'll pass it on to my young friend who's going to Croatia at the same time as you.
That's right. Tom W0NI, and I will be in Croatia at the same time you are, Jim. And I'll be there. So I'll send you an email about that, and I can send you my link here so you can follow where I'm at. I will do that. Nothing else to report. Go ahead, Bob.
Bob W6ACU, talking about 6 meters. I worked Pitcairn Island the other night during the board of directors meeting on FT8. And I just have a very modest setup. I have a 7300 and a Comet with those small beams at 15 feet. And I still just do very well. It's amazing. And just one last thing is talking about some of the expeditions, Austral Islands. I worked them on 4 bands within 10 minutes last night. It was amazing. I mean, it's very strong signals. So
DX is that you can't hear the pilot. At least I couldn't hear the pilot.
No, no.
20th Street South almost.
Yeah.
And I can't hear
Call you back, Joanne. I'll call you back.
Yeah, Peter, you're next. Go ahead.
Oh, yeah, a couple of things. Talking about 6-meter EME, you had a member, Bruce Clark, who was very active on EME. He's a member of the San Diego DX Club. He moved down from Palos Verde. He was a good friend of mine. He actually had an opportunity to use the Stanford dish. And also W7FM up there in Mercer Island, he also was active on 6-meter EME. He may still be. Also, I probably should add, I have a 6-meter WAS number 28, and I have one of the handful of guys that worked EI2W Ireland back in the 60s on, they were on for 2 days, came through 2 days. So I'm proud of those contacts. But anyway, thank you very much for your time, and I really enjoyed the meeting.
All right, thanks, Peter. Okay, it's time for the drawings. Tonight we have a hat from the Northern California DX Foundation. They gave it to us. We did a donation. For those you don't know, we did a $1,000 donation up there. They sent us a nice little letter, and they were nice people. Prez gave them the check. We have a Red Trolley Ale. This is a local ale made here in San Diego. I've never had it, so I can't tell you whether it's good or bad. And I'm not a big beer drinker, so probably couldn't tell you it was good or bad anyway. And then we have a Cabernet here. So for those of you who haven't been here to do this, the first person picked out of here gets to pick what they want. The second person gets to pick what's left over, and the third person gets what they get. All right.
That's nothing.
I always do. Twice. The beer down the beer. Yeah.
Hi, I was in a Zoom meeting and I couldn't talk to you.
That's a good beer, Tom. Drink it in good health. Tom doesn't have to buy beer.
Right. It's over. It's over. Oh, yeah, yeah. No. No, you need it. Anyway, how was your meeting with the ranch manager? Oh, okay.
One last thing. 2.5 weeks ago, we were in Dallas. Oh, yeah. You actually got your photo.
Oh, okay.
I'll bet. Also, if you guys are gonna put your fees to
Yeah, it's good to see you. You look good.
we built one of those QSL boxes in.
Yeah, one here, crock pot.
So we got 3 of them there. If anybody wants one, take one. Otherwise, it's going in the recycle.
Correct. Right.
Finish it up. Okay. Well, thanks everybody for coming. And it's going to be, this is an excellent presentation. It'll be on our YouTube site in a couple of days, but tremendous presentation. And thanks everybody for coming.